All right, good morning, and welcome to Metal Forming Magazine and PMA's fifth annual Internet of Things experience for manufacturers. This year, again, presented as a series of educational webinars. I'm Brad Kuvan. I'm the editorial director at Metal Forming Magazine and PMA, and I'm pleased to serve as your moderator today and throughout the webinar series this week. Before we get started, just a few notes about today's go-to session. The meeting and all of the others in the webinar series are being recorded for archiving, and the recorded event will be posted to our website at the conclusion of the webinar series later this week. We will let you all know via email when the recorded webinars are available for viewing online. You'll also be able to get PDFs of the presentations from our website as well. All participants in the meeting are on listen-only mode. That means that the speaker and other attendees will not be able to hear any audio from your site during the program. However, you can communicate with us throughout the program by submitting your questions and comments using the question box, which is located on the right-hand control panel of your go-to screen. So you'll simply type your question to an organizer as selected from the drop-down menu. Then you'll use that same question panel to ask questions of our speakers at the end of each presentation. Lastly, before we get started with our presentations this morning, I want to thank our event sponsors, Komatsu and UNIST. Without their support, we would not be able to bring events like this one to you, so a big thank you to both of those companies. So now it's time to begin this morning's session, and we begin with a case study titled Zero Downtime, Zero Defect Manufacturing. And it features the story of how SAF Holland is bringing the IT function to its plant floor to use production data to drive zero defect manufacturing and traceability. Our speakers are Mo Ablali, CEO and Managing Partner of IoTCO, and Isaac Bennett, Director of IT and Digital Transformation at SAF Holland. Mo is going to kick things off for us this morning. He's got a 20-year record of achievement driving and sustaining change in manufacturing by providing digital transformation, industrial IoT, and predictive analytics technology and services to manufacturers. After Mo speaks, Isaac will take over and tell the Industry 4.0 story at SAF Holland. Isaac's worked in the IT field for nearly 20 years, and he's led several global digital transformation initiatives to help plants around the world implement smart manufacturing projects. Please note that Isaac's presentation is pre-recorded, so if you have any issues with the sound, just make sure that you're listening to Isaac through your computer speakers and that you have the volume turned up. All right, so we'll go ahead. Please welcome Mo and then Isaac. Mo, take it away.
Brad, thank you very much. It's always a pleasure to speak at the PMA events that you guys are hosting. Our organization, in a simple one-slider, focuses on Internet of Things and Industry 4.0 technologies. Our DNA is really the automotive and discrete manufacturing industry, and I'll be sharing use cases today around machining and stamping, and some of the relevant case studies to PMA members, in addition to having Isaac Bennett kind of tell his story on how they're going toward the Industry 4.0 journey at SAF. So our organization focuses on providing IoT, predictive analytics, as well as an academy for performing assessments and training. Okay. Our presentation, we'll discuss four things today. First and foremost, the business case for Industry 4.0, and specifically focusing on predictive analytics and leveraging artificial intelligence on the factory floor, followed by what is the technology behind it, and kind of an advice on following a systematic approach to win return on investment by leveraging AI, which actually will be strengthened by Isaac's presentation, which will take us through a digital transformation story or journey of his activities. So let's go ahead and get started. Internet of Things is by no means a new field. It's a new naming, maybe, but IoT is all around us. You know, jet engines in the skies are being monitored, residential homes are being monitored, power plants are being monitored. The use of sensors and data and analytics to deliver an ROI for the business, and also in highly and safety regulated industries like power generation and aviation, for example. But where we play, and I think most of the audience here, is the industrial Internet of Things, or IIoT. And in IIoT, you have a factory operation and you have an IT OT stack. IT is your information technology, like your ERP system, for example, and OT is your operational technology, like your machines, your CNCs, your PLCs, your stamping presses. The issue, or sometimes the challenge, which is also an opportunity, is how these layers can converge and talk to each other. You may have heard the term shop floor to top floor integration. So to do this, real-time connectivity is important. Manufacturing execution systems and IoT platforms are important. And once we are able to kind of assess the maturity of these layers, we are able to start thinking about implementing advanced analytics on the factory floor, okay? Leveraging artificial intelligence, leveraging machine learning. So we really like to consider 4 things when we are implementing a digital or an analytics strategy. I like to start from the right and go backwards. You know, what is the return on investment? What is the business case from implementing such a solution? Where or how connected is my factory? What type of data do I need to capture to make this happen? Keeping in mind some machines are new and some machines are legacy, old, and they need to be instrumented. And then the role of analytics. And today I will talk more about predictive maintenance as an example, and Isaac will discuss more types of analytics. And then technology. How can we create a template that is scalable for the rest of the business and can be scaled quickly and affordably, okay? So this is really the story that's setting the stage from IoT to industrial IoT to the Industry 4.0 movement or initiative, all the way to the strategic thinking about how to implement these solutions. And my focus today will be around zero downtime factories and how to leverage predictive maintenance. And predictive maintenance as a market has been extremely hot and growing. This is one of the leading market research entities out there, and it's showing an annual global market growth of almost 30%, mostly coming from the manufacturing sector. So it is a big market, it is a growing market, and this is coupled with the fact that sensors are getting cheaper. Data acquisition is getting cheaper. Cloud cost is getting cheaper. So basically, sensors on hardware costs are decreasing. Compute power is decreasing and becoming more powerful. And this is allowing manufacturers, large and small, to embark on this zero downtime and Industry 4.0 journey. But again, it all starts with a justification. It all starts with a business case. And we've conducted a survey for some of our key manufacturing clients, over 100 of them over the past, let's say, 3 years, I believe, and the type of improvements they have seen by implementing AI solutions in a pilot. And a pilot usually runs for about 3 months, 3 to 6 months. So within about 90 days of implementing these solutions, improvements in not only OEE, but labor productivity by reducing paper on the factory floor and improving digitalization of the operation. And by implementing predictive maintenance, for example, the ability to detect and predict issues before they happen and sustaining a high level of uptime, especially if you have assets that are uptime critical, and 1 minute of downtime is very costly for the business. We have also seen manufacturers that are integrating the predictive data back into their maintenance system, their CMMS, SAP PM, IBM Maximo, Infor, whatever you're using today. But there's an opportunity to reduce spare part inventory, and there's an opportunity to improve mean time to repair, and also to do predictive scheduling. So the ability to optimize your PM windows and to allocate the right person to fix the machine before the machine fails. There is also a growing trend of predictive quality and the ability to reduce scrap on the factory floor by correlating machine data and quality of the part that is being produced. We have a stamping manufacturer, for example, that has cameras, images. We call it image AI, and they're taking a picture of a part that is being stamped or welded. And by looking at the image data, you're able in an automated way to use AI and to detect and predict scrap on the factory floor. So innovative ways are there, creative ways to help companies drive toward a zero downtime, zero defect mode of manufacturing, and truly achieve over 100% ROI within a short period of time. So a lot of folks out there are doing this today, right? You have your PM cycles, you do product testing, you do manual inspections. Some are using SPC, some are monitoring process parameters. So these traditional methods are great, but it also allows a foundation to start going toward leveraging that data for predicting maintenance issues, predicting quality issues, and also optimizing your process, right? Optimizing the recipe that's running on the machine, optimizing the process parameter settings to ensure that you're making parts in a more precise way. So we've seen that trend over the past few years, and our focus today in this quick presentation is to just scratch the surface and talk about predictive maintenance. But definitely, if you're interested, there's opportunities also to talk about predictive quality and predictive process optimization. What is the technology behind it? It's really a three-layered approach. You know, regardless of the solution that you select, it starts with data. It goes into the industrial AI application, and then it goes into specific use cases. Okay, so it's very important to create the solution in a user intuitive way in order to kind of go toward that zero downtime, zero defect journey. Okay, and the data model is very important, right? These solutions are not over-engineered. There are specific data parameters that may be coming from the PLC controller, maybe add-on sensors like vibration that would be added to specific areas of the press, for example, like the shaft, the transfer motors, and other critical components. I mentioned the use of cameras or image data, which is basically unstructured data. So an AI solution should have the capability to bring in structured data, unstructured data, PLC data, add-on sensors data, and build a baseline based on all these different parameters, and then contextualize and convert it into meaningful metrics for the maintenance and quality team. So what is the health of my machine? When is my machine going to fail, which we call remaining life prediction? And what is a diagnosis? What is the root cause? And these are three key metrics to drive toward a more proactive maintenance activity. You know, I won't go through the process, but just on a very high level, there is an analytics process behind it. But nevertheless, we do not expect the end user to be a PhD or a data scientist. These solutions have evolved to the level of allowing the user, a regular user, a maintenance professional or a quality professional, to understand health and prediction and diagnostics, and to work with the tool without the need of having an advanced degree. Okay, that's really the goal, to design for the user a user intuitive implementation, and this will lead to very successful projects actually. And I've picked two examples to show today in a limited time. One of those examples is actually machining, and the other example is stamping. Okay, but there is really a breadth and depth of applications where you can start implementing process monitoring and predictive maintenance and leveraging artificial intelligence tools. Each one of these templates, be it robotics, machining, casting, molding, welding, stamping, or any of these ancillary equipment, has a data model behind it. There are specific parameters that have been well studied for many, many years that allow you to take that data model from the PLC, or maybe add vibration sensors to the machine, and start creating that machine health model to allow you to become predictive and preventative for your operation. And a quick example is actually machining, grinding machines, milling, lathes, whatever that might be. it's a complex asset. There's a lot of moving parts. You have spindles and tools. You have your linear axis, your ball screw. You have hydraulic and coolant systems where you might have a motor or a pump, or the coolant itself, the lubrication, right, to be monitored. So there is an ability to have multiple templates here. Some of these require add-on sensors, like using vibration monitoring to monitor the spindle, to monitor the tool, while others, like the feed axis or the linear axis, actually does not require any add-on sensors. There are specific parameters that are captured from the machine controller, like the position of the ball screw, for example, which will allow you to have very accurate predictions on, is the ball screw failing? What is the reason? Is it a preload loss issue, lubrication issue, starvation issue? Multiple different failure modes. Okay. And a quick view of the type of data captured is actually shown here for an example CNC machine. If you are using CNCs today, you know, the use of vibration sensing, the use of current, feed rate, position data is actually important as part of the data model. And then there's different ways to capture the data. You might be using MTConnect, you might be using OPC, and so on. But what I wanted to show is how intuitive these user interfaces should be for the maintenance organization. Again, what is my machine health? When will my bearing going to fail? In this case, it's an example of a bearing on the main shaft of the press machine, for example. Or it could be a motor, it could be a pump, it's a bearing. So having a predictive window and also the ability to diagnose the root cause of the bearing failure is very important. So these AI solutions can actually predict and detect if you're having an inner race failure of the bearing, or an outer race failure of the bearing, or a cage failure of the bearing, which sometimes is important to understand how your bearings are behaving, and to even talk to the bearing suppliers like SKF or Timken or whatnot, and improve the bearing design and improve the way your machines are running. Okay, but it's also important to see here that AI solutions generate automated thresholds. You can see yellow and red. These are automatically generated thresholds by an AI model that are allowing the user to automatically receive notifications and alerts in a predictive way, and to see a window where they can react, and they can create a work order, and they can fix the machine in a proactive manner. Another example, which in closing could really apply to some of the folks attending today, is press machines. You might have hydraulic presses, mechanical presses, servo presses. You might be using Komatsu, Schuler, IDA, or whatnot. Weiner Weingarten, which was bought by Schuler. This is an example of an automotive OEM, but we're also working with tier 1 suppliers like Shiloh Industries and others, who have had successful implementations on their press machines, and we're able, or this client is able, to detect and predict issues within a short period of time. And one of the issues was actually detected and predicted almost 1 month in advance. And I think in a future webinar, we would love to bring in, together with the PMA, for example, Shiloh Industries, to tell their story. And this is just showing you an example of how that process runs, right? So this is the data model I was referring to. Information about the angle, the pressure is very important. In some cases, we're collecting temperature data and oil data. So it is truly a multivariate analysis that builds a baseline of a healthy press machine and trends that over time, so that in this customer, for example, there was a failure on the press that was detected and predicted almost a month in advance, and it was related to the locking hydraulic component on the machine, and this was detected and predicted almost 4 weeks in advance. So that picture on the bottom left here is actually the press health index, and the true realization of it is right here. We're allowed to show this publicly. This is actually showing that 1 month prediction window where the client actually used the software to detect and predict issues, and the stamping press was fixed, and the AI solution actually auto baselined itself and then after the repair was performed, and then it continued running the press machine. So some of the advantages here are detecting and predicting issues that can be costly for the business, almost within a 4-week notice, sending predictive alerts to the maintenance team to be more proactive. This manufacturer actually integrated this predictive data to create predictive work orders automatically in their CMMS system, which were flagged as a predictive work order, not to be confused with the PM work orders. And that really allowed a more proactive way to manage their maintenance activities. So many great examples of actually implementing AI on the factory floor to predict maintenance issues. And before handing it to Isaac, I just want to rest on this slide and say the National Association of Manufacturers, NAM, they actually created an award category for AI. It's called the AI Analytics Leadership Award. And we've seen automotive clients, large and small, receive this award since the inception of the award in 2019, actually, every year. Most recently, McLean Fog on the hot forging and machining lines that they have, they were able to use vibration-based monitoring to detect and predict major issues on their forging lines. And I wanted to show this slide because there is really 4 keywords here that you should keep in the back of your minds when you implement these solutions. Number 1, what is the technical value to my business? How can I help my maintenance and quality team members do what they do better and more efficiently? Number 2, velocity, speed. How quick can I implement these solutions? Can I do it in 3 months, or do I need to start implementing now and it takes me about a year, which is not feasible, not a good thing to do. So implement quickly and scale quickly. Think big, start small, scale fast. And how quick can I generate ROI? So if you're interested in any of these case studies, we can definitely share them with you. So what I mentioned is really, what I talked about really is a case study driven approach of what is happening in the industry today. But what my colleague Isaac is going to talk about is he's going to bring us back to the foundation, and he will not just talk about technology, but he's going to talk about some of the challenges of doing this in real life. And it's about people, process, technology in that order, and not just about technology. So I'm going to hand it off to Isaac to tell his story. Thank you.
Thanks, Mo. I appreciate your introduction. I appreciate everything that you talked about. I always feel like I learn something new every time I hear Mo present. So it's always a pleasure. But yeah, my name is Isaac Bennett. I am the head of IT for the Americas for SAF Holland. SAF Holland is a company that makes semi-truck parts, suspensions, landing gear, fifth wheels. So it's a pleasure to be here today. Just a short introduction about myself, and you heard Mo present, and I really like to kind of present my story in a way that it can be relatable to those of you out there who are starting on this adventure of Industry 4.0 or smart manufacturing. You might be new to it, or you started and you were kind of stuck and you're looking for where to go next. So I kind of will like to tell my story so it's relatable, you understand where I'm coming from, and it's kind of a real world example of my adventure down the path of Industry 4.0. So yeah, I've been in IT for 20 years, in automotive for about 10 years, and my background is IT, so I'm the IT guy, and that's what I always tell people. I'm not, of course, I've got 10 years in automotive, but really, I'm going to come from the aspect and from the perspective of an IT journey, and I'm gonna show you how I got involved so deeply into Industry 4.0. The one thing that I will say is that in Industry 4.0, if you look at Industry 4.0, it can be very overwhelming. There's a lot of aspects in Industry 4.0. If you look on the outside of that ring, you look at cloud computing, that can be kind of overwhelming. Artificial intelligence, as we're talking about, big data, additive manufacturing or 3D printing, augmented reality. There's a lot of different aspects of Industry 4.0, and if you just look at it from a high view, 50,000 foot view, it's going to be very overwhelming. It can be significantly overwhelming, and it can kind of put you in that status of, kind of get frozen of just looking at all the cool stuff in Industry 4.0 and trying to figure out what should we do. And the point of this is that I wanted to say that really at the core of Industry 4.0 is going to be data analytics. That's the core of it. That's what drives the engine, is the data that you're going to be able to get from any aspect of Industry 4.0. And I make this point, and if you read that little quote there on the right side, especially today, and I probably pulled this quote up a few years ago. This is before the pandemic. And being in IT, you inherently know and how quick IT shifts and changes. And as we're implementing more and more IT kind of technologies into the manufacturing process, it's almost like we have to, as manufacturers, also think about how we can adjust and how quickly we can adjust. And so the point being that, the internet is so quick these days. The internet gets better and better and better. I remember the days when wireless would be kind of spotty. We first had wireless, but wireless is really solid. The internet in general, information travels very, very fast across the world. And because of that, economies change fast, governments change fast. Everything is really rapidly moving. You saw during COVID, especially in the IT world, everybody's like, oh, I have to work remotely. What are we going to do? And we were able to shift rather quickly to a lot of people working remotely and working from home and working offsite and being able to still collaborate and work. And that's just one example of how quickly we had to adjust when the pandemic happened. This is not just unique to the pandemic. I mean, any kind of change, we're going to have to be quick and agile and easy to change. And how do we do that? And how do we make decisions quick and easy? And generally, it's going to be through the acquisition of data. And so I wanted to just make that point right now, just to say that I know it is a big obstacle, trying to figure out what to do. And so I'll tell you the story, and I'll leave this slide up there, and I'll skip a couple slides ahead as I'm telling the story. I'm not going to specifically talk about the stuff in this slide. I'm going to talk about the concepts. So as an IT guy, I was actually in the facilities in our European facility. I was the head of IT over the Europe and South Africa facilities. And basically what that meant was I was the manager of the IT guys in the plants in Europe and South Africa. So I was managing those guys, making sure they're doing their jobs. And in that process, I quickly found out that making friends and trying to figure out what the needs of the business were, making friends with the plant manager and the plant controllers to make sure that I was in alignment with them. They knew that they could come to me with their concerns. And also I knew that my IT guys were doing their job because they really needed to be, in some ways, reporting to the plant managers if the plant managers had issues within the IT systems in the local plant. Excuse me. In one of those conversations I had with the plant managers there, the plant manager was very adamant about saying that he really needed IT to be more involved on the manufacturing floor. And we had some conversations about that, how that could be done. And generally, the IT guys were going on the manufacturing floor only to maybe fix a computer that had been broken, and then they would leave. And he made the comment about how you know, they were trying to figure out how to produce their product better and more efficiently. And their guys that were on the manufacturing floor were starting to connect the machines, collect data, and he needed to figure out how we could best use that data. So I actually came back from that to the US. It was an expat assignment for 3 years. And I actually came back to the US. And when I came back to the US, I got sent back actually a few months early. And because of that, I didn't really have a full-time position that was back in the US. Part of the position was managing the US IT people in the plants, but there was only 2 facilities. So in the process of that, we had a global IT meeting where we talked about how IT could better align with the business. And I said that the IT, the managers that were in Europe, plant managers were telling me that they needed IT's help more on the plant floor. And so that turned into, okay, what can we do? Which then turned into a big presentation that turned into, at that time, before I even knew what Industry 4.0 was, it turned into a presentation about Industry 4.0. And what we quickly realized as an IT organization, and we started having a lot of discussions about this, is that the OT, as you can see there on the top left, IT and OT, operations technology, they were not even talking generally to the IT people. And you know, the OT guys are sometimes putting even in their own networks that were completely separate from the IT networks, so they could connect the PLCs together. They were putting SCADA systems in. They were pulling data off and putting into HMI. I've run into a lot of guys that are OT guys that basically taught themselves how to program so they could build HMI screens from back-end access databases. And they weren't involving IT at all. And so we quickly realized that we needed to really sit down together with the IT and the OT guys together and figure out, hey, if we're going to get data off the manufacturing floor, how can we do this in a secure, safe manner and make sure that all those standards are being followed and that we're in alignment? Because a lot of times I found in the facilities and the plants that those IT guys and OT guys would even butt heads because the OT guys are throwing switches in, IT guys are complaining about them. That typically was the case. So that was one of the things that we talked about. And then it kind of expanded. It expanded into the conversation of really, if we want to get the best use of that data across the organization, that we need to break down more than just the IT OT silos. And you talk about matrix organizations, and you know, one of the reasons they're popping up so much lately is the digital transformation initiatives. Really, departments need to break down those silos so they understand each other. They understand what data is coming from them. They need to work together and collaborate more and figure out how to automate more. And that's always going to be cross-functional. So we figured out pretty quickly that Industry 4.0 is not just in the silos of just a manufacturing plant, but if we're going to start looking at more automation and that data going throughout the company, that we're going to try to figure out, we need to figure out how to break down silos. And so you can see examples up there that we found real quick that some plants have a manufacturing execution system, some don't. Departments are not collaborating. Sometimes data is gathered, sometimes it's not, depending on the plant and location where you're at. And so there was no standard solution. You talk about Industry 4.0 and the core of that being data and data collection. There was no standard solution for that data. How was it being recorded? How it was being collected? And so that was a big concern of ours. First of all, the silo of IT and OT, and then the rest of the silos that were happening around the company. And so you see, we started thinking about this as not just an IT problem, but across the value chain issue, needing to connect all those things together. And you talk about supply chain. Supply chain is a huge issue these days, and being able to collaborate between different departments and understand between customer service and warehousing and production. When is that going to come off the line? Do we have the material to to be able to sell that product in a timely manner and an on-time delivery and all those things that will require, if you have automation in place, will require, or trying to get automation in place will require a big team effort in a matrix organization that you break down those silos and figure those problems out. And so then we started thinking, okay, we know this big, huge concept, Industry 4.0. We know at the base of it is data, and we know we need to break down these silos. But then where are we right now? And that was a big conversation as well, as where are we right now in the path of Industry 4.0? And you can say this is just a one single facility or multiple facilities, but the one thing that I did really discover is I said, okay, we're going to travel around to the different facilities and we're going to look at the processes of those facilities, and we're going to try to figure out, where are your low-hanging fruit? Where are the problems? Where are the gaps? The gap analysis, you could say, of our Industry 4.0 and the different facilities, and it's really turned into a big discovery and also a big learning experience for myself as an IT guy. We went through the process, mapping the process of different facilities. And facilities generally hadn't done this, but we really went through every step of that process and say, okay, what are we measuring? What data can we get? And what problems are we happening within the facility within that process? So that's really, that right in itself is a standalone manufacturing when you're just looking at one single line, one single plant. And I'll give you an example of, I went to Mexico to look at their process, and they really wanted to start doing traceability. And we spent 3 days looking at their processes. And they really wanted to do traceability so that they could try to match the quality with some of the data that they were gathering. And through that 3 days, we at the end of the 3 days, we gave a presentation, and the presentation really turned into a maturity presentation, because the plant manager at the end was like, hey, wait, I thought this presentation was about traceability. Presentation was about the fact that they had PLCs in their casting area that were not even connected to the network. So we basically were putting a case out there that said, the maturity isn't there yet. It doesn't make sense for us to start marking parts through a manufacturing process if one of the most important parts of a manufacturing process is casting, and we're not even collecting data from a casting machine to match it to what's happening with that wheel or with that part when it was manufactured. And so then we went back again and said, okay, we need to do an analysis and say, what is the maturity and where are we at? And this is kind of a busy slide, but it kind of shows you of the beginning and the end of kind of Industry 4.0 of where we want to go. And we talk about the value chain and that supply chain. So you can see on the right side there that number one is reactive automation. That's not even, we don't even consider that in Industry 4.0, but where do you want to be? Smart manufacturing, manufacturing excellence. Yes, we want that, but then we want to spread that. We want to maybe have a pilot plant, a lighthouse plant, spread those standards of site excellence to other facilities, connect them together, be able to share data between those facilities, and then start looking at even your global value chain, and then even your ecosystem. It's a long path, and you can see there at the very top we had 2011, and you can see all the way to 2017 was kind of what we were thinking our path to Industry 4.0 was. As we went through this entire process, and as I went through this process with myself and the IT department, which turned into then a business initiative, because we talk about breaking down silos and the importance of data and how do we collect data, and then assessing those plants, going through their processes, looking at their maturity and where they are on the scale of Industry 4.0, and then what can they improve. So we kind of had this big picture of where we're at. So then you go back again, and we said, well, let's break this down, because it gets overwhelming. Industry 4.0, all these plants, where are we with the maturity? And so we said, let's break this down and try to find a business case for us to do a really solid initiative for smart manufacturing. Right now, where I'm at right now, and I'll tell you what we're doing in the Americas region at SAF Holland, is we really don't have a solid documented processes. So we're kind of back there where I was when we need to talk about that Mexico plant. But and the things that we're looking at strongly are just starting to collect that data. A lot of that data now is just being written down in spreadsheets. And then pushed into the ERP from a written down spreadsheet and manually entered. And we're talking about, we talk about the automation pyramid, and we really, in these plants here in the Americas, need to start with just starting to collect some of that data from the manufacturing floor directly, and then automating that into the ERP system. So that's really where we are. And so the idea is that, look at the top bar right there. It says think big, start small, prove value, scale fast. And so that's really a big message. The technology, I always say that the technology is the easy part. Of course, coming from an IT guy, but really putting the technology in is always the easy part. It's the hard part is really figuring out the process with the manufacturing facilities. And I think Mo said it when he said people, process, and technology. It's hugely important. I can throw technology at anything, but if we don't have a people process, the right people and a right process in place, at least understand what that process is, it's really hard to put in technology that people will actually use and get value from. So hugely important. But yeah, that's where we're at right now. We just need to collect that data and start seeing that data flow into the ERP system. And then the second part was making sure that ERP data is standardized so that we're all seeing the same thing, making sure that we're seeing the same thing. So this is an example of a manufacturing execution system and MES system. There's a lot of things that we could be doing with that, and I think we'll be starting with a couple different small parts of this and being able to, that we have screens in place, easy to use. That's a big deal. You talk about, the manufacturing facilities and an operator that's on the manufacturing floor. You want to make sure that, especially with high turnover these days, that person can walk in there and relatively easily use that system, that you're still able to collect that data, and that data is, people, process, and technology, right? You want to make sure that that process is set. They get the right people, and they can come in there relatively quickly and start touching that screen to put the right data in that you're collecting. But really, the next step for us is going to be, and Mo talked about it, is predictive analytics, because we don't have that foundation of data yet. Once we get that foundation of data, we'll be able to start doing cooler things and more advanced things with Industry 4.0. And I'll tell you a quick story of one of the facilities that I worked at. That we worked in a facility in Akron, Ohio, and they were in a similar position. And they had a very, very old machine that was kind of a bottleneck if it broke. I think it was a 50, 60-year-old machine. I mean, just post World War II, and it was a steel rolling machine, roll forming machine. And so we wanted to test this theory of, can we actually predict when a machine's going to fail? And this was a cool story because it was an old machine. So it proves the fact that you don't need to have new technology and spend a ton of money on a new machine just to get the right data. And we were able to retrofit this machine with some sensors. And specifically top tooling and lower tooling. And we sat in a room and decided, not only are we going to focus on just this one machine as starting small, the small project, we're going to focus on the specific area of this machine that normally breaks down. So we were able to get those sensors on this machine, on the top tooling and lower tooling section of the machine, and plug it into the network, send that data to the cloud, into a data analytics system. In a matter of 3 months, I believe, we were able to train the system to where we believed we had a good working system that would predict when this machine was going to fail. The funny part of the story, I guess that's not funny if you're the production guys, but they predicted it was going to fail on a particular day, and the guys in the production team that were involved with this project said, okay, let's see what happens. And indeed it failed exactly on that date as it was predicted, and they were down for I think 6-7 days, so it was a relatively big amount of downtime. So that was a real good learning lesson for us, and that this is it can be done. This is real world. This is not just a concept. This is something that can be very useful and really show a good business case in the future. So that's really my biggest message is like it is complicated. If you sit there and analyze all the pieces of Industry 4.0. But if you focus on the fact that it is really this data is the center of what Industry 4.0 is, that's the foundation. And the second part is to have a big picture of what you want to do, but you don't need to spend a ton of money. You can start with a small project. Look for those machines that are standard machines across the business, across the plant. Look at a machine that might be a particular problem or a particular part of that machine that's a problem, and you can start with a small project. Sensors are inexpensive. That's one of the reasons why Industry 4.0 is taken off, is because that technology has got to the point where you can buy a sensor for relatively inexpensive and put that on a machine and start pulling data out of it really, really quick and getting value from that. So that is some of my biggest messages. But lessons learned, as I said, think big, start small. I always say start small, and also you fail small. It's okay to fail, especially if you're failing small. Failure is part of innovation, and it's you can't have innovation without it. So I always say think big, start small, and you can fail small, and then scale fast. People, process, and technology. Really understand your people and your process first. Don't just start doing traceability just because. Let's understand your process. Let's understand your people that you have in place, and then let's fit that technology and make sure that technology is going to work. And then focus on ROI. I mean, that machine, we focused on that one particular machine in Akron because that was a big bottleneck. And that was an easy win for us. If we could prove the technology, that was a real big, easy win. And as I said before, for me, the technology is there. We just got to find the right business case, the right process to put it into. So that is my message to you today. I think that's my last slide. So I really appreciate the opportunity to speak here today, and I think I'll turn it back over to Mo.
So we are up against it a little bit time-wise, but I do want to ask, and if anybody has any questions, please go ahead and use that Q&A panel. We'll do the best we can to address them here. But leading into our next presentation, Mo, I thought maybe you could address software tools for making this happen. Industry 4.0 technologies, IoT, and AI-enabled predictive analytics are leading edge tools, obviously. Can fabricators, stampers use existing legacy software tools, as Isaac spoke about, his existing MES and ERP, for example, to support those types of initiatives, or are you seeing folks using a new approach to software tools? I think you're muted. I can't.
Okay, you can hear me now?
Yes. Yep. You might want to turn your computer speakers off.
Yeah, I think I'm getting echo from someone.
Is that me? Nope, that was me. Sorry.
Yeah, so to answer your question briefly, we usually assess the different layers. So what type of data collection is happening today at the stamper? Do they have an MES or an IoT type of solution? What is the ERP system they're using? What is the maintenance software that they're using, if any? And it might be part of ERP, it might be separate. And then we don't want to rip and replace, we want to complement. So we look for areas that we can coexist and integrate. So for example, on the data collection layer, you might be using an OPC historian like a Kepware, or you might be using MTConnect to read data from your machines. You might have invested in an OEE software like a SensorTrex. I think they will be presenting tomorrow. So we don't want to replace these areas, but we surely want to see ways to collect data from your existing systems, and we want to feed data back to your existing system. You might be using eMaint as your maintenance system and so on. So it's truly a complementary approach, and it all starts by assessing what the manufacturer is doing today.
Gotcha. Okay. Very good. All right, Mo, thank you so much for your presentation today, and we'll make sure to thank Isaac as well. Yeah, excellent presentation. So we'll go ahead and queue up our next speaker. Our next presentation addresses Industry 4.0 from a little bit different perspective, and that's we're going to discuss how the adoption of Industry 4.0 and the collection and analysis of plant floor data impacts the workforce of tomorrow. Our speaker is Fred Tillman. Fred is the Vice President of Product Development for ECI Software Solutions. During his career, Fred has led the development of several successful commercial software products specifically for manufacturing, as well as for asset management, government procurement, e-commerce, aerospace, and the healthcare markets. Fred's primary motivation, he says, is to create enabling and collaborative environments for technology professionals and customers that want to make a difference in the world. So please welcome Fred Tillman. Take it away, Fred.
Good afternoon. So my session is what industry data tells us about the promise of Industry 4.0. You've heard some of that earlier this morning, and the new skill requirements of the workforce of the future. So again, I am Fred Tillman, and I lead the product strategy and development at ECI Software Solutions. We at ECI, this will be the one plug you'll hear, our industry experts supporting the entrepreneurial spirit and profitable growth of small to medium-sized businesses. So we really focus in that small to medium-sized business area. We do this through ERP and other related business software. I would like to mention and give credit to my co-author, Dwayne Clement, who is the CEO and founder of Data Inventions, which is an IoT and data analytics partner of ECI. So let's start with a little bit of an agenda for today's presentation. The first thing I'd like to do is go through a 2021 digital transformation survey that we conducted. Then we'll talk about technology trends in Industry 4.0. I'll kind of put my own personal bias and opinion on that part of the presentation. And then let's talk about some real application, and machine intelligence is an area that I think anyone can get started with, and then end with a success story. So on the manufacturing survey, again, we surveyed small to medium-sized manufacturers on their digital transformation journey. We had 500 plus respondents to the survey, and this survey was conducted a couple of times, March 2020 through March 2021. So fairly recent data, if you will. So the top 5 concerns that came out of the survey, the first one was COVID-19, not a surprise. That had a huge impact on the workforce. As Isaac said, people, went and figured out how to work remote, but you also had to work with, fewer employees and social distance in those manufacturing floors where you just could not work, at home. Number two was supply chain concerns and issues, and that's becoming ever increasingly more important as we see the shipping containers pile up in our California ports. Number three was skill shortages due to retirement. And number four was skill shortages due to a lack of applicants and interest in the industry. And so it was interesting, you know, rather than grouping a skills shortage into just one category, it was very apparent that there were two very deep root causes to that. And then last but not least was cybercrime. So, you know, taking that top item, COVID-19, what did people do? What was the impact of that? Well, 45%, you know, made more financially conservative types of decisions, if you will. 42% adopted, where they could, a remote workforce model. You know, again, for those employees that was feasible. They increased investment in technology and infrastructure. Again, we're living in a connected world, a more remote world now. The younger generation of employees is requiring more flexibility in the workforce, and so we're seeing that increase in investment. 26% unfortunately had to lay off staff, and 26% similarly took on more financial risks. I won't go through the rest of these, but you can see what the top impacts of the pandemic were. So all of that kind of combined said that manufacturers had to do more with less. And again, doing more with less really is, I think, finding and applying Industry 4.0 technologies that can help you increase productivity, competitiveness, and you know, allow you to focus your workers on higher value-added activities. So 37% of our respondents said that they added skill requirements to handle emerging technologies. So hiring people that understood, and we'll get into what some of those technologies are here in a little bit. 31% did downsize their operations, and 25% is they have made a concerted effort, if you will, to attract younger postgraduate applicants, if you will. So again, message here is that we are really having to do more with less. So SMBs are investing in technology as a strategy to, one, manage budgets, maximize employees, enable that remote work, and improve cybersecurity, which was number 5. And proof of that was really we're seeing an upward trend in our manufacturers in their technology investment. And just as a point of reference, we did this survey in 2019, and the spend increase was almost twice that of 2019 in technology investments, if you will. So you can see that 45% of our manufacturers have increased their technology spend in the area of 25 to 49%, which is a pretty significant up. 25% went as far as to increase it 50 to 74%, if you will. And then, of course, 4% almost doubled their technology spend. Now, as Isaac and Mo pointed out, you know, technology is sometimes the easiest piece, and it's the easiest piece to spend money on. But there are challenges with adopting technology. And so the survey, you know, we asked our manufacturers, what were those top challenges, if you will. So 41%, you know, were concerned with cybersecurity risks, opening up networks and information on the shop floor to the top floor. Sorry, Mo, I stole that from you. You know, and doing that in a secure way that protects IP, and in some cases, you know, our national security, if you will. 26% did respond that they weren't experiencing any challenges. So that was, you know, good to see that there are a quarter of our manufacturers that feel like they are in a position to handle this new technology. On the other hand, about a quarter said they don't have the dedicated IT department and team to implement the new technology. 20% do not have budgetary resources. 20% do not have internal expertise required. And so hopefully, you have some good partners and software vendors that can help you on your journey there. So again, there are some challenges in adopting this technology. So let's talk a little bit about, our journey here. And I think that this is probably a repeat for some folks, but I think it's always good to go through this. If you looked at, we're kind of in our fourth industrial revolution, if you will. So, industry 1.0, mechanical manufacturing, steam powered machines, that really was a game changer. Industry 2.0 with the mass production, assembly lines. Electricity was a big impact, on manufacturing. Industry 3.0 was IT automation, computers and electronics shorten production time and reduce the cost. And really with Industry 4.0, we're now in a space where we are combining the cyber, if you will, the digital with physical systems. And that's really where the Internet of Things comes in, data analytics, business intelligence, if you will. So really Industry 4.0 is a new world and shows a lot of potential. So we saw a slide earlier about what Industry 4.0, there are a lot of different technologies, if you will. These are the kind of the top 6 for me, if you will, but cloud-based software, security, connectivity, global reach for your global manufacturers, a lot of agility because you can scale very quickly in the cloud, and API connectivity. So being able to connect systems of different, capabilities and locations around the world very quickly, if you will. And then number 2 was connected machinery, machine-to-machine connectivity, often performing actions without any kind of human intervention, if you will, both increases efficiency and reduces cost. Advanced data analytics, that was mentioned as kind of the cornerstone earlier of kind of the Industry 4.0 technologies. To me, this is the ability to do dashboards that you can gain insights from, drill down capabilities, filtering, what if scenarios, and doing that all on data from multiple sources, if you will. Number 4 was artificial intelligence, and there's different applications, if you will, for artificial intelligence. So, classification, which is really identifying which category an object belongs to, for example, spam detection, diagnosis, text labeling, if you will, regression, predicting a continuous valued output, collaborative filtering, filling in missing entries of user item association, clustering, dimensional reduction, which is very important in removing noise out of images, particularly in manufacturing quality applications. Number 5 was IoT devices, really preventative maintenance, as we talked about earlier, increasing the OEE of your machines. And then finally, virtual and augmented reality, which again blends kind of the digital and the physical world. Some of the early applications of that are in maintenance and repair, also providing access to more senior technicians, again, back to that retiring of the workforce, being able to leverage that experience, bringing in someone into the conversation while you're doing a repair, for example. So these are all kind of the kind of the 6 big ones for me. There are many more ones might include in that. So, our vision, or my vision, if you will, is right now, these technologies are of varying maturity and difficulty, and we really want to try to make the shop floor, a manufacturing shop floor, work like a cell phone, and you could run your business from anywhere, even on the beach. And the reason that I think that that's here and now, why not? I mean, everything is connected. We have that connectivity here. Software in general, you're able to choose your apps. If you look at your cell phone, you have different functions in your life that you download different apps, and those apps easily communicate through APIs. So you can now very quickly deploy different applications to solve your business problems. Of course, alerts and problem fixes notify you when you need to do work, and access anywhere, anytime. So it just works. So really, our vision is to really adopt Industry 4.0 in the same fashion that applications have been developed, in the cell phone space, if you will, or the mobile space. So now that we've kind of talked blue ocean, big picture, kind of in the future, I think we need to kind of come back and get a little bit grounded in the here and now. And of those, technologies that we talked about in Industry 4.0, I think the ones that are the most mature and you can actually utilize today are, number one, low-cost sensors and connectivity. So you can get those vibration, temperature, sound, other metrics, off of your machines and bring that into your data analytics platform. The ability to consume and collaborate and collate through massive amounts of new data, if you will. So network speeds, processing speeds, if you will, are allowing us to do computations and filtering on data that was not, imagined just a few years ago. The automated data analytics influenced heavily by connectivity, network, hardware, data, different standards for doing that. And then finally, applications, because all that data and all that connectivity is great, but you need somewhere to analyze and gain insights. So these are the four technologies that I think are really here and able to use today. So this allows us, I think, to answer some questions to old problems. The inability to use or analyze your data, poor data quality, which affects your decisions. Users don't get enough information fast enough, and unable to meet customer demands. And siloed data. Isaac mentioned it in his presentation, but quality, quoting, CRM, order management, scheduling, maintenance, data analytics, documents, all of this siloed data. So 89% of IT leaders say that data silos are an obstacle, and only 20% of applications at a manufacturer are integrated. So I think applying 4.0 technologies definitely can address this particular problem. Of course, you may be saying, oh my goodness, big help or more headache. The last thing I need is more systems, more data, and more reports. I think one of the key messages I would say on the implementation side is that you need to start with what you already have. If you can't use the systems you have effectively, adding more stuff in is going to make it that much more difficult. So, adding more stuff, just not the right place to start. Once you take charge of your information and get it working for your people, then you can fill in the gaps and build from there. And so that's really, how do I get started? What do I need? Where do I do to start? What options do I pick? And how do I put it all together? And you really need to look for a vendor that has that experience in integrating those systems from your IoT devices all the way through to the applications which allow you to gain insight. See how we're doing on time here. All right, so what I'd like to do is then, a little bit more on the journey, if you will, for implementing a machine intelligence solution. That was, item number 3 on our agenda, which I think, taking those Industry 4.0 technologies that I said were mature and now turning those into really a successful solution. And that's really what you need to do here. So you really need to start with shop floor data and data connectivity. It really starts with your ERP. Many ERP systems have shop floor entry applications to collect time, materials, labor, that type of thing. And then connect that again with measurement devices through APIs, which is one of the key technologies. Certainly, some devices now operate at the edge, which means they're operating and making decisions and transforming data right on the shop floor. Some are uploading information to the cloud for further analysis. Other manufacturers, for various reasons, need to operate on-premise or hybrid. So you really need to figure out and inventory your current data systems on your shop floor. And then the next piece of this is really to acquire sensors. Many of the modern machines and equipment have this capability to monitor them built in. Others you'll need to add sensors, if you will. And some of the connectivity options you have is LoRa, Wi-Fi, 5G, MT Connect, and so forth to connect those devices. That's done, of course, through gateways and routers and standard protocols. Your network folks are gonna love you when you do that. But really establishing that shop floor data collection and connectivity is step number one. Also part of step number one then is connecting that to your data analytics platforms, if you will, your BI and data analytics solutions, if you will. That was back to the dashboards and the drill down capability, because data, if it's not presented in a good format, is not going to allow you to draw those actionable insights. And so you really do need to have that visualization of the data available to make real-time decisions. So the second step is you have to engage the entire team, and I agree with the previous speakers. People are the biggest component of a successful implementation of a machine intelligence initiative, if you will. And so you really do need to engage them, share the expectations, benefits, the goals, and the resources. So my suggestion on rollout is training of operators and supervisors on using the system across all shifts. Having metrics, clock in, clock out, parts counts, downtime, non-conformance. These are the metrics that you need to establish baselines for and monitor. And then as this gets underway, I suggest daily huddles, standardize the work, weekly progress updates, registered item lists, and then lastly, to really engage the employees, celebrate successes. Recognize those employees, those champions, if you will, that are helping you implement your machine intelligence solution, and then develop a cross-training matrix, because you really do need to spread that across your team, if you will. And again, human nature, the shop foreman, show me, performance versus targets and expectations now, so I know where to focus. So tell me what is happening, why is it happening, what are the actions to take, and then support me. And these are all the things that your system or your Industry 4.0 should do for your shop foreman. And once you do that, they're going to be a champion of yours, if you will. So continuing to address the people side of this really is to develop an improvement toolkit. We talked about daily huddles to understand how we're doing, analyzing the metrics we're capturing, analyzing our standard routines, making those more efficient, and then assessing the staff skill level and training, both cross training and also original training of those staffs, and then build confidence and show the data analytics. When we implement a machine intelligence solution with our manufacturers, we see generally about a 15% improvement in machine efficiency, really a 3-month payback and 10x ROI on implementing these machine intelligence solutions. And so let me talk a little bit about, a success story then of our machine intelligence solutions. So here's our current situation. I don't think anybody would argue with this. Manufacturers lack the information they need to reach their full potential, and that really, in North America, companies operate at an average OEE of 40%, which many in the world, that's less than half of what world-class standards consider acceptable. So we really want to get that machine utilization, much higher. And so, what is the the issue here, if you will? So you have a success story, machine utilization. So this simple diagram tries to get a little bit into the human element. So the operator employee, when they look at their line, their machines, their productivity, they think, wow, I'm 100% productive except for my lunch break. The manager looking at kind of heuristics and kind of historical patterns and frankly sometimes gut feel says, okay, well, I know that it takes some time in the morning for the employee to get going, at night, and his estimate is that his machines have a runtime about 5.5 hours or a utilization rate of 68.75. But when you actually hook up your IoT machines with your ERP data and really drive those insights, you see that runtime is about 3.5 hours on average, or a utilization of 43.75%. So you really do need to have a machine intelligence solution to help you identify, things such as, why was machine setup time longer than average? Why was labor not available at the time it was supposed to be? Why was the machine down? Was it maintenance? Was it scheduled? What was the issue there? And then also, just the material and scrap usage and so forth. So combining all of that together really gives you those insights, which again, we have seen manufacturers see a 15% increase in machine utilization just by making sure that parts are there, the labor is there, the machine is up, and you can see these gaps in your productivity and address those with the staff. So, a success story. Complexus Medical is a company that has taken advantage of this machine intelligence, if you will, and their CEO quote here was, and by the way, Complexus Medical makes medical devices, if you will. They're headquartered in Indiana, and they really wanted to get better efficiency of their machines, and so this is a quote shortly after their implementation. We already see a dramatic increase in machine utilization in our business. Some areas are up 15 to 20% and are now in the high 60s as far as the machine utilization. And we're able to make these improvements, within weeks. So again, I think the Industry 4.0, while there's a lot of hype, I think there are industry solutions, particularly around machine intelligence, that are actionable now and can provide you with great, efficiency, if you will. So hopefully you learned a little bit about what the manufacturing industry is thinking about, where they're spending their money. Hopefully you learned a little bit about what hype or reality on Internet 4.0 and really how to apply machine intelligence in a successful way. And with that, I will turn it back over to Mo, actually to Brad.
Yeah, I'll take it from here. Yep, thanks, Fred. Thank you very much. Yeah, excellent presentation. A good perspective on manpower requirements to implement machine intelligence. What type of machines was Complexus focusing on when they were looking at OEE? Do you know what types of machines they're working on?
I believe it was drilling machines was the first place that they started.
Okay. All right, good. So we have a little bit of time for questions. If anybody wants to throw them Fred's way. We've got about 7 or 8 minutes here. You can use that question panel on your go-to screen. Fred, we talked a little bit with Mo about connecting machines, implementing IoT or AI strategy using legacy software systems versus, I guess, you'd say maybe state-of-the-art software systems. What do you see kind of some of the big differences between connecting, using IoT with legacy software versus, more state-of-the-art systems?
Well, I think, the biggest thing is just the different types of data that you can get off of those, if you will. Many of the legacy machines don't have the ability to electronically transmit measurements, and so you do have to buy third-party sensors, if you will, to apply to those particular machines, if you will. So that's the primary mechanism. And really, there's a number of companies out there that you can contract with that will come in and provide that service, if you will, and hook up the legacy machines, but also hook up your more modern machines so that you don't have to have a complete, retooled IT staff with large networking skills in order to hook these up. That can be something that you contract for.
Sure. Okay. Question we always get related to this type of technology is ROI. So I don't know if you want to use Complexus as an example, if you know, or just in general, what do you see in terms of ROI when people are implementing, whether it's low-hanging fruit, OEE type of system, or a more sophisticated machine intelligence?
Yeah. So, the way that we've calculated ROI on the machine intelligence solutions that we're talking about here is we'll often see an immediate, like with Complexus Medical, 15% productivity improvement. And so that results really in an incremental utilization of that machine of about 6.75%. So your OEE goes up to 52%, which translates into about 1.08 hours per day. So to drive that down into dollar figures, an average facility, and we say average facility, somebody with about 25 machines, 2 shifts, and a $75 an hour shop rate. The average annual value per machine is about $20,000. The average value for that facility as a whole is about $500,000 or $500,000 in increased, efficiency and operational effectiveness of your machines. So again, significant return on investment just by having the visibility into how parts, labor, and machines are interacting and how efficient.
Sure. Very good. Okay. Any more questions for Fred? If not, all right. Well, Fred, thank you so much for that presentation. A lot to think about there. Thank you for joining us today. So that concludes this morning's webinar session, part 1, if you will, of what is a 5-part webinar series on Industry 4.0. So I want to thank our speakers, thank our sponsors again, Komatsu and Munis, and of course thank our attendees for joining us this morning. We hope you found it to be a valuable experience. Again, an archive of today's program and indeed the whole 5-part series will be available at the end of the week. You'll get an email from us, so you'll be able to review it, share it with others within the organization. So we hope you'll be able to join us this afternoon for part 2 of the series, which includes a presentation on digitization for the die shop, and then a panel discussion. We've got 4 industry experts that are going to join us this afternoon to share their perspectives on IoT on the plant floor and in the press room. So please come back and join us at 2 o'clock Eastern this afternoon. You can go ahead and close your browsers now, and we'll see you in a few hours. Thank you. All right, good afternoon, and welcome to Metal Forming Magazine and PMA's 5th annual Internet of Things experience for manufacturers. And if you joined us this morning, welcome back. This year, the event is presented as a series of informational webinars, which we're holding throughout the week. My name is Brad Kuban. I'm the editorial director at Metal Forming Magazine and PMA, and I'm pleased to serve as your moderator this afternoon and throughout the rest of the series this week. As I mentioned this morning, this meeting and all the others in our webinar series is being recorded for archiving, and the archived event will be posted to our website at the end of the conference. That'll be later this week, probably on Friday. We'll let you know via email when the recorded webinars are available for viewing online. Also, all participants in the meeting are in listen-only mode. That means that the speaker and other attendees cannot hear any audio from your site during the program, but you can communicate with us by using that question panel on the go-to screen. You'll simply type your questions and comments using that question box. And then you'll use that same question box. Just select as an organizer when you type in your question, select organizer from the drop-down menu at the end of each presentation. Lastly, before we get started, I want to thank our event sponsors, Komatsu and Unis. Without their support, we would not be able to bring events like this one to you, so much thanks to them. So now it's time to begin this afternoon's webinar with a talk on CNC digitization and the impact it can have on the tool and die industry. Our speaker is David Darling. David is with SimSource USA, and he stresses that continuous improvement and technological innovation are not merely one-time achievements, but rather they are a business culture of their own. And I'm sure that's the overriding theme of his presentation today. David spent nearly 15 years in the automotive industry working for Daimler Chrysler, and then worked as vice president and COO of Autodie before he joined SimSource. So please welcome David Darling.
Thank you very much, Brad. I appreciate it. Really happy to be back with PMA. We were just talking kind of leading up to the webinar going live here. And I kind of think about at different stages of my career on the technology path as there have been big developments. The Precision Metal Forming Association and Metal Forming Magazine has always showed great interest in that. I think that's an awesome service to the readership and the members. So that's great. So thank you for having me here today. I'm going to do my best to get through this. It's a pretty complicated material, but I'm going to try to make it as approachable and as interesting as I can. And I'm going to start by offering you some context. First, I know that Brad said a little bit about my history, but I need everyone on the kind of call to understand I'm one of you. This is my world. This is where I came from. I was born and bred in manufacturing engineering for Daimler Chrysler. Worked my way up into getting a chance to run this beautiful facility that you see here, kind of the Willy Wonka of the tool and die world, where our presses were on the small side, 180 inches by 1,000 tons, and there was about 30 of them, I think, and they went as high as 3,000 tons. So big machines, big presses, big products. And I would like to say that my favorite flavor of chips are not barbecue nor cheddar. I like the fairest kind, and the bluer the better. So I am really into machining is what I'm telling you. And really also something else I want to talk about because it's important to the topic at hand. And I know you're not here to listen to me talk about tool and die today, but I can't help but do it a little bit. I firmly believe that the success or failure of tool and die manufacturers in the United States is entirely based on them achieving excellence in two areas: metal forming engineering and CNC machining. If we don't, as a country, and especially this industry of metal forming engineering, if we can't become excellent in those two things, we have a very tough road to hoe to survive. So I'm going to offer you just my frame of reference. At my time at Autodie, I was a really big adopter of technology. I saw that the path to us reducing our labor burdens lied in mastering technologies, simulation and die design, but also in machining. You guys, I really believed that unless we got up to snuff with our machining, we didn't have a chance in hell. And the company believed me. It was the largest non-new model investment they ever made in a single plant. It was $24 million in a bunch of brand new state-of-the-art milling equipment. Now, while it's really awesome that that milling equipment was way faster than the 1980s relics we were running, it wasn't about the speed that got me interested. What was, to me, important was the business process that it supported. They enabled this thing that I'm going to call the digital feedback loop. You see, I believed that for metal forming in the United States, we needed to reduce our labor content and be excellent technologists, which is why I'm here with the Internet of Things conference today. And those machines were critical because they allowed this kind of PDCA cycle, right, of engineering, doing the NC programming, verifying it, cutting it, validating it, and trying it out. You see, I really believe that the more we could rely on machines and technology, and the more we could reduce human content, the more we could validate this circle and become really, really excellent in reducing labor content and improving our speed to market. So I'm only offering you that as my frame of reference about why I care about CNC digitization in general. Number one, time, obviously, right? Where we're saving a lot of time by reducing prove outs, we're saving machine tool operator time, programming time. The more we go digital, the more time we save. We increase product quality, we save money, we increase productivity, right? The more we can optimize those machining times and increase those material removal rates, the more successful we're going to be in our businesses, right? We're interrupting production less frequently. The list goes on, right? We're building confidence, right? We're testing our parts. We don't have the guy sitting there with the hand on the feed override like he's playing an instrument or ready to hit the oh shit button. We're conserving resources. We're improving our safety and our training, right? And we're also improving our record keeping. If we get really good with our CNC data, we can start not only doing job setups and things like that, but we can keep getting really good at our record keeping as it relates to costs, assigning them to jobs, maintaining, and really getting better with predicting our tool wear. The limits, you guys, the information as it relates to the record keeping portion of this, too many to mention here, and that's not why we're here. So when we talk about NC digitization, what are the best practices? Specifically, what am I talking about? First, I'm talking about NC verification, right? I'm talking about getting a chance to think through and engineer our cutting approach and validate it. I'm a big believer in independent validation outside of NC, but again, that's not why I'm here. But we want to master NC verification. We also want to get into tool management systems, right? Think of it like a digital distributor sitting inside of your factory that controls your tooling data, gets it to where it's got to go, whether it's in CAD/CAM programming, whether it's in managing your crib, whether it's in presetting, and whether it's going to production. We can find efficiency the entire line across if we're using tool management systems. The next one is standardized NC programming. When I talk about that, I am talking about using very detailed models of our machines, of our tool holders, of our tools, and quite frankly, getting to the point where we're automating our NC programming by standardizing our cutting approaches on common tools. If you're in metal forming, like draw dies, for example, the more we can standardize our NC programming, the more reliable that NC verification process becomes, the more accurately we cut our tools, the more accurately we bring them to press, we get real results, and we get feedback into the system. It's all based on NC digitization. So this is where the title of my presentation comes in, the big oversight. If you guys are all sitting there, and I know we can't do this, we're not in a live audience, but if I were to ask you, what is the one thing, the one common thread that runs through and between all of those best practices? It's one thread that they all share in common, and without it, none of them work. Tool data. It's about tool data, you guys. If you want to get into the Internet of Things as it relates to digitizing your NC practices, if you don't have a plan for how you're going to obtain and manage tool data, you're dead before you start. And that's what we're here to talk about today. So when I say tool data, let's calibrate what that means. Number one, it's basic information. It's photos of your tools. It's maybe PDF files. It could be catalog information. It could be target information like data. It could be two-dimensionals, it could be drawing, it could be CAM exports, it could be technical parameters. And if we really want to get advanced in what we're doing, we can start getting into application data. We can start getting into speeds and feeds. We can start getting into tracking our tool performance over time, right? These are all examples of the sphere or ecosystem of tool data. So when I say what is tool data, I'm saying it's parameters. I'm saying it could be, if you're a vendor, right? None of us on this call necessarily are, could be sales collateral, could be speeds and feeds information, could be graphics and CAD information. It could be stock levels. There's a lot of information that goes into what tool data is, and managing tool data is difficult. I don't know how many of you are on this call or watching this webinar have started going down this road yet, but you get into a lot of challenges with this. You get into, number one, questions about specification, right? What do I need in my environment? What does my machinist, my customer need, right? My programmer. What information do we actually have on hand versus what do we need, right? How do we need the information, right? We got to get into data format, right? If we want our data, let's just say if it's a graphic of your tool to read into your CAM system, you got to know what your CAM system needs in order for that to be a reliable depiction, right? So how do we need the data? And are we even able to provide the data into the system that we currently have, right? So it gets to be very complicated. And if we look at just I put this slide together when I'm talking about just an average tool and die facility, right? I know the one that I came from was a little bigger than most, so I scaled some of this down, right? So let's say you're a typical tool and die facility, you're maybe doing some of your own maintenance, you're doing some of this technology stuff. You maybe have a couple hundred tools, maybe a dozen suppliers. Each one of those tools has dozens of potential parameters. I mean, if we just want to talk about the 3D characteristics of the tool, you could be talking as many as 50 measurements to properly define that end mill or that shoulder mill, right? And then on top of that, no two vendors that you have use the same parameters. So if you wanted to compare one to the other, you couldn't even do it. If you wanted to read one into your CAM system, then you take the other vendor in, one of them's not going to work because they're not the same. Let's pretend that you have two CAM systems. I know that's not really uncommon, right? One that maybe the guys or girls are using on the shop floor, some being done by maybe your programming department, maybe some for big mills, some for small. Let's pretend you're printing some setup sheets, but the bottom line is you can see the number of potential data points that we're talking about, and now, really for them to work, you need them for your system. You just don't need the data. You need the data in a format that your system can use, that your systems can read in, that can pass between one system to the next. It needs to be customized to you. Basically, you need a click and go solution, right? So what makes matters even worse is that you have this, I'm going to call it the X times Y interface problem. Let's say you have systems across the top, right? 1, 2, 3, keep going on as many as you want. Let's pretend one's your ERP system, one's your TMS system, one's your CAM system. Let's say you have a second CAM system, right? And then down below, you have your items, your cutting tools. Obviously, there's a lot more than 2 of them, right? But each one of them having hundreds of parameters in and of themselves, we then try to do that, right? We're now multiplying each one of those. Let me back up a minute for the animates. We're trying to take each one of those systems times each one of those basically items, and we're needing to come up with a set of parameters that's going to work for all of them, right? And that's where this gets really, really tricky. How do we find a standard interface that will allow all of these things to work kind of cohesively, I guess, pass the information from point to point to point down the value chain and do their job? So what I know a lot of you are probably thinking, which is what I started thinking before I dug into this, which is, yeah, that's fine. We have international standards, right? I mean, there's ISO, there's DIN, the Japanese folks have theirs over there, right? Like, isn't that good enough? The problem is that it's not, right? If we want to talk about international standards, we're going to use the IN statement. They're incomplete. Most of them were developed at a time prior to really thinking about technology. That wasn't the function of the standards. They're not flexible. I mean, they have committees that don't meet super frequently, and I don't know that they're designed to be flexible. And they're also oftentimes interfering with one another. And last but not least, they're also very complex, right? So when I talk about that, I'm going to say, here's the proof of why the international standards don't work. I found the picture on the left. Pretend that those are all cutting tool manufacturers. I don't know what they are. Or on the right, there's a typical data site where you can go and look for tooling information. How have machinists, NC programmers, since the beginning of time, go back to the manual milling machine days, early of Ford, when we wanted to find tooling data, the first thing we had to do was know the tooling manufacturer, right? If we want to look for an end mill, we have to know what company we're going to find the end mill so we can then look it up. The reason it works that way, you guys, is because the data structure and how the tools are defined, drawn, and contemplated by each manufacturer are different. So you can't go to one source to look across all because you're going to be comparing apples and Twinkies. It doesn't work. So the other thing about international standards that makes them a little bit not sufficient for what we're looking for today is also they really only speak to geometry, right? Again, these standards were contemplated at a different time and for a different purpose. They weren't contemplated with the function of technology. They weren't contemplated with NC machines and feeds and speeds and cutting depth and chip thinning and chip loads. I mean, it wasn't designed for that. That's not what they were for. But yet, when we look at that and we look at things like order size, when we look at pack quantities, when we look at what we keep in our inventory, all of those things are very important for our business today, but yet they're not a part of the normal international standards. So what does that leave an end user to do? An end user needs to have a plan to obtain the information. Now, what we see a lot in our business is we see companies rushing ahead with simulation for their NC programming. We see them going to Bearcut and independent solutions. We see them getting really involved in programming. But what we end up, and also this is the latest, we also see them making massive investments in tool management systems to contain the chaos and put an order to it. The problem is that they don't realize until they've made these investments and gotten pregnant with the idea and start rolling that they don't have the information that they need, that the standards don't give them what they're looking for. And now it comes time to populate these systems and use it, and they're stuck. They become digital paperweights, right? So what normally has to happen? Well, the end users realize that they have to obtain data. So on goes this frantic rush to go out and get information. You're typing emails to your vendors, you're calling them, you're getting whatever you can get. But what you don't realize is that there's a lot more involved. You don't just have to obtain it, you have to enrich it, right? Because no two vendors have the same data. And honestly, you guys, most of them have not very good data. So what you're going to get is almost never going to meet your needs. You have to enrich it. And once you enrich it, now you're comparing these databases, you're building these databases, each one of your tools, all of this information. Well, what happens if there's a number in there that's wrong or something's transposed and it creates a CAD model or reads in a factor or a number to your CAM system that causes an interference? What are you going to do? Well, you have to verify all that information, right? So you're obtaining it, you're enriching it, now you're verifying it. And then last but not least, you have to format it. Now that you got it, you've enriched it, you know it's good data, now you have to get it into the formats that your systems downstream are going to need in order to work properly. So there's a lot more there besides just getting. So when I talk about enrichment, here's some examples, right? From my company's perspective, we talk about number one, tool in hand, right? What is it that when I'm holding the tool, I can see? I can see geometry. I can see interface codes, right? How one tool assigns to another or links to another, right? Think holder tool relationships. And then we get some basic CAM information, right? And then beyond there, we get to tool on shelf information. We get into things like logistics. We get into accessories, spare parts, parent-child relationships. We get into delivery data, stock quantities, things like that. Beyond that, we go to our next category. Our next category then becomes tool in use, right? It becomes process information, machine processing, workplace, workpiece materials, speeds, feeds, all of those types of things. Those are all examples of tool data. So what we talk about is there's a minimum starting level. If you guys are going to get started going into CNC digitization, you have to at least be accounting for geometry in a reliable way. And not just reliable, but in a robust way is the word I was looking for. Beyond that, now you get into some basic informations that we're saying you're looking good, right? Looking okay. You're getting into some interface codes, you're getting into some graphics, getting language cleaned up as stuff comes in from different companies around the world. Beyond that, now you start looking better when you start getting into some CAM level information, 2D and 3D geometries essentially ready to go into your CAM system, right? Because the minimum starting level, guys, when I say geometry up above, that's just measurements, that's call-outs, schematics, 2D information. When we get to level 3, where I say you're starting to look better, you're getting into solid models that are going to be appropriate for your CAM system. Now, where you start looking good is where you start getting into things like logistics information, and you start getting into machining process information, right? Like, what kind of material is this tool good for cutting for, right? All of those types of things. You start getting, you're really heading on your way. And then last but not least, you've really gotten to the point where you're cutting edge, no pun intended, where you also now reliably capturing speed and feed and performance by tool, right? So long story short, I hope I've thoroughly overwhelmed you by now, because that was kind of the intention. What I'm talking to you about right now is where CNC digitization falls on its face and it stalls and a lot of times dies completely. Vendors are overwhelmed with inquiries coming from people just like you trying to build these databases. And quite frankly, most of them don't have the infrastructure in terms of people or information to fill these requests out and get them back. And then also the companies who invest into the digitization for themselves oftentimes realize that maybe they spent a couple $100,000 on that TMS and maybe $100,000 on that verification software. And now they realize they got another $300,000 to go to build their databases and hire the people. And they realize it's too late. Projects oftentimes will die or they get stalled here. We many times have walked into facilities where they have been stuck in this exact position, sitting on an unused asset for 24 to 36 months before they finally reach the point where they're crying for help, asking for uncle. So the things I need you to say are takeaways so far is that if you're going to be, and this is purely to be take home for you, this is the one freebie out of this that I hope really everyone takes with them, that if you're going to go into CNC digitization and you're budgeting a project, whether it's a TMS project or a Vericut or some kind of other project, CG Tech project, you also have to have a plan of where you're getting your tooling data, including a budget for how you're going to get it, and really a key resource, a person that's going to manage it and make sure that it's accounted for, communications are happening between your vendors, and that also they're building the database and they're doing the debugging. It's something that it's the price to entry if you're going to go CNC digitization at all. And then also, while I'm going to tell you is, yes, there is data available in the cloud, whether that's the machining cloud or your vendor's cloud or whatever cloud, it doesn't matter. It's a generic one size fits some data structure, and it will not. It's not up for debate. It's not wondering. It will not seamlessly work within your environment without additional engineering time. If you get a one-off here and there, and if your environment's really, really simple, possible, but it's a bad plan. Unless you have a way to get that stuff customized, it's only a matter of time before you get burnt. This is where I'm going to say I transitioned. I jumped past that slide. This webinar thing is giving me a little bit of a hard time here. There is an alternative. Shameless plug. I'm going to make it fast just to show you kind of how else this could work. And the reason I offered you my frame of reference when I started this is because I am a big believer in technology. And when I chose to get involved with a new firm, it was because this firm had the solution that no one else had. And that is what SimSource is doing. So the company I'm from is called SimSource Digital Tool Services, formed in Germany more than 30 years ago by some really brilliant folks who saw the problems that I'm talking to you about today 3 decades earlier and decided that they were going to fix it. 2 products that we have in the market. One is called Tools United, one is called Tool Link. Tools United was developed basically as a single source, 100% complete tooling supply chain solution from the tool manufacturer to the tool user, right? So how do we go from where it is digitally, from actually the manufacturer to your digital to your real life? And in other words, our sole purpose in being is getting the manufacturer's tool data to you, the end user, precisely where you need it, when you need it, and in the format you need it in. We don't sell tools. We're not in the business of that. We are simply in the business of making this whole process of moving data around the market and within your environment as seamless and as simple as it possibly can be made. We are not data in the cloud. We are the world's most comprehensive and most flexible standard. And when I say standard, I mean engineering standard for material removal tooling. Oh yeah, and by the way, we have a website, right? We are not just taking and publishing what the world gives us. We are an engineering standard that tries to account for all of this. We are an engineering standard that takes in the best that DIN and ISO have to offer. We take in e-commerce information, we take in speeds, material groups, applications, and we take in all of the actual CAD modeling, and we make sure that we can produce reliably for you a piece of data that will work within your environment. If you can think of it this way, you have something like DIN, you have something like ISO. Think of SimSource in our standard open base as kind of being the mother that sits above them. It takes into consideration all the things that the rest of the market doesn't take into in one master standard that then can feed the rest of the market right downstream. And I'll show you what that looks like here real quick and I'm done. On the upper left, behind the third pane, you see a search screen from Tools United, wherein a user has gone in, they have worked their way down our tree, they have found end milling cutters, and they have pulled up. So the first thing I want to show you is all they have to do is go into end milling cutters. They have, I think, a dozen parameters that they can pick from overall diameter to length. There's all kinds of information from which they can choose to narrow down their search. And then what it's going to do is it's going to comb everything in the Tools United ecosystem, and it's going to show you everything that meets that. So remember when I said the way we used to look at tooling data, we'd have to go to a catalog. We have to know what we're looking for. What this is doing is it's now showing you here in this search that I pulled, it grabbed all, what was that, 5, 6 vendors right there, and all of those different options, right? So it allows you to broaden your search in terms of the things that you're looking for and the things that you're finding and the types of tools that are out there for you. The next thing it allows you to do is build assemblies, right? So right inside of the system, for me to take and build this assembly that you see here, which is just a collet chuck, a collet, and a drill. Intentionally, when I built this one, the collet chuck is from Walter, the collet itself is from Python, and the drill is Sumitomo. I click the button, it renders me the assembly, and then I can go ahead and I can export it in standard formats like STEP and ISO, or I can go specifically to my CAM system with things like Mastercam. The list is long. There's 13 of them that we could go to right now and counting. So that is basically the way the system works. Thank you very much. I don't know how I'm doing on time. I had every intention of keeping track of it. I got distracted, but it looks like I'm about right on the 30 minutes, Brad. Thank you. I appreciate it.
You bet. You bet. Thanks, David. Yeah, we have a little bit of time for questions from the audience. If anybody wants to ask David any questions, go ahead and use that panel, the question panel on your GoToControl screen. So the validity of data, David, I hadn't heard this discussed in IoT, but boy, it sure makes a lot of sense before you're pouring data into populating a system with it. How do you know if the data that you're collecting is valid and real before you wind up, putting wrong data into your system?
Yeah, I mean, it's an interesting question, and it depends on, remember, the tooling data ecosystem is vast. We're talking about things like geometry. So let's just look at that example, right? So you are going ahead, you are compiling, you are downloading, you are contacting your vendors, calling your reps, and you are populating these databases. One of the things that you have to pay attention to, let's just say in the world of the tooling geometry, is a simple transposition, a missed decimal, a number in the wrong point can create relationships between measurements that basically do not compute, they do not function. And when you try to read them into your system, oftentimes it's not until you try to use them that you find out the mistake you made. Hopefully it's something that's determinable by a graphical representation that you can see. Sometimes it ends up resulting in an interference, a collision on the machine. The best way to go through that, honestly, is a quality gate system where you are actually checking and reviewing incoming data. And without our system, the only way I know how to do it is manually. And that's where I say you have to budget to have people, a key resource kind of shepherding this thing along. One of our two products that I had on the screen there, one of them was called Tool Link. Tool Link is built precisely for that service. Basically, it allows a user, like someone on this call or a shop or a machine shop or die shop, to basically compile a list of the tools that they need and define the types of parameters that they need from those tools. And what Tool Link will do is it automates everything I just told you you have to do with quality gates. It goes out to the Tools United universe, finds everything it can pull in, populates all of your parameters, it highlights the ones that you're missing, and it also does quality checking on its own. It has relationships that it understands between measurements and between dimensions, that if they are out of compliance, it flags and says you have a data quality issue. So we have tried to automate as much of that as we can. But if you're not using our products, unfortunately, it's like any other kind of product development process. You have to have a gatekeeper, you have to have quality control, somebody's responsible for signing off on it and getting it into the system. Those are the two ways that I know how to do it.
Other than some of the manpower or organizational structure that needs to be in place, in terms of a gap analysis to implementing this type of technology, where do you see the hurdles when you're trying to work with a potential customer?
Yeah, so it's funny. The honest biggest hurdle we come into is people who just don't understand what they don't understand. They didn't have the benefit of hearing what I just told you, right? They're oftentimes an executive, somebody like a stuffed shirt like I was at Autodie, who said, yeah, go automate, go digital, and I'm gonna sign the recs and I'm buying the stuff. And then they realize I don't have the information necessary to make any of it work, right? So the biggest hurdle we come into is that commercial hurdle where people haven't budgeted and prepared for this part of the project. Now, beyond that, I'll tell you that there are still limitations in industry. Not every tooling vendor is created equal in terms of their preparedness to support you. Some of them are real cutting edge. You look at Sandvik, you look at Walter, they're far along the line. And honestly, they're using SimSource to power that for them at the vendor level. But they're doing really well. But I'm telling you right now that there are others, they're still referring to paper drawings or prints trying to answer your questions. So that, to me, if I'm a vendor, is going to make me really nervous, because the vendors who are not prepared for this transition are going to find themselves out. Because we do a lot of research, especially in Europe, they're a little more ahead of us on this. And what a lot of those major manufacturers are saying is, if your data isn't available for us to do digital, right? If it's not there for us to prove out, if it's not there for us to verify before we order, we're not ordering from you. And they're just cutting vendors out altogether. So I think that we're in that dichotomy of tension here of the vendors aren't really ready, but we're not kind of pushing on them as hard as we quite need to yet, but it's ramping up more and more every day. I mean, I see the traffic that comes into Tools United. I see Smith & Wesson visiting us. I see massive defense contractors visiting us. The people are out there searching for the problem or the solution. The issue is they don't entirely understand the problem yet.
Interesting, okay. David, you said that each CAM system will have its own data requirements. How do you know the attributes needed and the most efficient way for collecting those attributes?
That depends on your circumstances coming into that question. If you're trying to do this on your own, luck, effort, fortitude, trial and error, contacting your CAM vendors, because again, like, I put myself into my position. Let me go back a couple of years. At Autodie, we were very automated. We used CATIA V5, right? So theoretically, if a model would be good enough for CATIA, it should have been good enough for us. The problem was it wasn't, because we had done so much customization inside of CATIA to automate for our good that a standard model would never work, right? So long story short, you kind of have to have an understanding of it. You're going to be calling your vendors. You're going to be doing some trial and error. I mean, we were at a customer who was implementing a major TMS system, and they were learning by trying to put things into their TMS and going, uh-oh, there's a big red exclamation mark there. That's not working. Why, right? So that's really the way you go about it if you're doing it on your own. Or you come to people like us, that's all we do, and we're pretty prepared because we have exports built for most of the major CAM systems. We have most of the TMS systems covered for and integrated with. We're a certified master CAM development partner. We work and do R&D. We're building our tooling libraries into their system. So if you're trying to do it on your own, you just got a tough road to hoe, I'm being honest. But there are people out there who can help you. And that's where I would advise you go.
Yep, gotcha. All right, good. Any more questions for David while we've got him on the line? Okay, all right, well, David, thank you so much for that great presentation. Kind of a different perspective on IoT for our audience, so I appreciate it very much. And David's email address is up on the screen there if you have any other further questions for him.
Yeah, please.
And again, remember, yep, go ahead.
No, I was going to say, number one, thank you. The website there, it says tooling data. I really encourage you to look at that. The reason being is it's an explainer video, kind of those neat animation things that kind of explains what I taught you here today. So if you have to go back to work, talk to an executive, be like, hey boss, this is the reason why we're in trouble, point them to that video. Because when they get there, they click play, it'll help them understand kind of what you're trying to tell them. And then if they put in their email address, it'll notify me, but it'll show them how we fix this for them. And then they can understand the gap versus where they are versus where they need to go. And it's a great tool.
Awesome. Excellent. Okay. Thanks so much, David.
Thanks, guys. I appreciate it. Thanks for listening. Take care. Have a good day.
All right. So now we're going to switch directions and welcome our esteemed panel to our webinar session. Our panelists from the metal forming and fabricating industry are here to share their knowledge and expertise as to where they see IoT and maybe the broader perspective on Industry 4.0, where it's all being used in stamping and fabricating shops today, where it's going to be used down the road, and the steps that y'all need to take to keep up with this technology as it starts to infiltrate our facilities. So our panelists this afternoon, our panel is made up of James Barrett. James is president of Link Electric and Safety Control in Nashville. James has 30+ years of experience designing and applying safety control and automation equipment for the metal stamping industry. And James is also a board member of PMA. Jim Finnerty is the product manager for Wintris Controls Group, where he's been for more than 35 years. He's responsible for new product development and sensor applications at Wintris, and also is an active member of PMA, serving on multiple committees, presenting at countless PMA technical seminars over the years. And you've probably seen him present at FABTech as well. Stephen Robertson is the general manager and vice president of sales and operations at Simpac America. Throughout his career in the metal stamping industry, Stephen's developed new automation processes and practices to uphold innovation standards and transform business structures for profitability. And last but not least, Curtis Liebensorger is a software developer at Komatsu America Industries, where he works in the machine press division. And in fact, Curtis created Komatsu's IoT platform, PressCheck, which is designed as a tool to diagnose and monitor machine press activity. So welcome, gentlemen. Thanks so much for being here today and participating in our discussion. To get things going, I thought maybe each of you could just spend a couple of minutes sharing your unique perspectives and vision for Industry 4.0 and IoT in stamping and fabricating operations. So James, you want to go ahead and start us off?
Sure, thanks, Brad. So IoT is already transforming the industry in a number of critical ways by lifting the veil that has shrouded so much of process information, functions, and equipment that can be practically improved, can be identified and acted on with confidence. Remote diagnostics and troubleshooting by equipment vendor technicians using real-time information from the machine can save a lot of time and reduce direct and indirect costs. Preventive maintenance can be effectively accomplished through reliable data gathering on machines and tooling, including removable tooling that may be used in multiple machines or even multiple plants. Hours run, hits on specific parts of a tool or the tool as a whole, tonnage trends, and these are kind of coming from a press-centric viewpoint, but for other types of machines, you could look at motor current when using rotating cutting tools, or pressure or flow in a water jet. There's any number of measurements that can be collected and usefully analyzed to prevent unplanned downtime and optimize maintenance cycles. Self-identifying tooling and automatic setup of critical machine parameters verified by feedback from sensors on the machine saves setup time and aids in error-proofing efforts. Setup times, production rates, and downtime information can be used to optimize processes and to feed back to ERP or MRP systems for better equipment utilization planning and scheduling. And in the reasonably near future, extended reality applications may let us synthesize all of this data into even more useful forms, especially, I think, in the areas of diagnostic and troubleshooting. It's likely that at some point when a machine reports a problem, you'll be able to use a set of holographic glasses or maybe just a tablet or smartphone and see a strobing red light highlighting the area of a tool or machine that needs attention, or perhaps indicating a specific punch that needs to be replaced along with its location in the tool crib. You've probably seen some demos of this kind of technology already, and efforts are underway to make this kind of application more practical to apply in general industrial environments at reasonable cost. So stay tuned for what's next.
Excellent. That was a pretty broad overview. Thanks, James. Jim, do you want to add to that or
and that's a tough
embellish a little bit?
I think one of the best starting places and one of the most important things you can do is just collect the data off your machines. I find it amazing that most places have no idea how often their machines are running, how often they're down, and what their true capacity is. We're going to talk about ROI later on. I had a recent user tell me that his whole software data collection system paid for itself 4 times over in under 3 weeks. And I found that rather hard to believe. And he said, well, we were considering buying another press. In 3 weeks worth of data collection, we found out that we didn't need another press. We had plenty of capacity. We just had to unlock it and pick sort of the low-hanging fruit and make our own product or our own equipment now more efficient. One of the things that's really exciting now is in the past, and I've been involved in data collection for almost 35 years, is the systems communicate with each other, and communication itself is improved. Data is collected in real time, and the information can be acted on in real time. If somebody's waiting for material, the guy driving the fork truck gets a text and says, press 5 is waiting for material. And the communication is improved, the downtime is reduced, and that has a huge impact on overall equipment effectiveness, or OEE. See, it's not the catastrophes that are killing everybody. It's the stuff you've gotten used to. It's the 5 or 10 or 15 extra minutes you're waiting for something every single day, multiple times a day per machine, that's really sapping the productivity.
Good, thank you. Stefan, how about you?
Oh, thanks, Brad. So like you said before, I'm Stefan Robertson, PM of SIMPAC and the VP of Sales and Operation here. And when we're looking at Industry 4.0 and IoT for the press room, we wanted to look into something that was user-friendly for people in the press shop, cost-conscious for our favorite friends in finance, of course, and also practical and feasible for everyone to use during these crazy times. Our vision was to use something that's already out there, so to speak, and expand on it. And of course, as I'm going to discuss a little bit more in detail later, with this in mind, and when I say by this in mind with we, I mean my inside sales and marketing manager, Jamie, on a company called Elm Park Labs that was taking AR, or augmented reality, and using the platform to help enhance our product, in this case a press, was bought off, and how a standard user could order spare parts and troubleshoot a problem by using either a cell phone or a personal tablet. We found that since pretty much everybody already knows how to use these 2 items, this would be the easiest and safest way for the everyday person, so to speak, to learn about and utilize IoT now and into the near-term future. It's not to say that ocular devices can't be used, and they probably will be in the future, just that we're looking for the most cost-effective and safest way for somebody like the everyday worker, all the way up to the craziest geek, to get involved in IoT today. And I'll wait for something that comes along sometime in the future.
Excellent. Yeah, I think making the technology more understandable and accessible to a broader range of people certainly makes a whole lot of sense in terms of getting it into the hands of the people that really need it. Curtis, you want to comment on what, your perspective on IoT and metal stamping?
Yeah, absolutely. So I work in the service department at Komatsu, the stamping division, and we really want to focus on creating applications that are going to help our service engineers better remote troubleshoot machine press issues. And how we think IoT is going to help us, it's going to give us bigger insight. So when a machine's down, we'll sort of know beforehand what tools and what parts we need to bring before we actually go to the site. And I also think IoT is really going to help us adapt to the new work culture. So how it was years before, people typically started with their job out of high school or college, and then they started, they did that for the rest of their work career. But now people in their 20s and 30s that were trying to get motivated, they usually switch jobs every 2 to 3 years. And then on top of that, not a lot of people like to travel and work, which is kind of a big issue when you're dealing with service and having to constantly travel. So if we could come up with a solution where they could see data and help remote troubleshoot press issues, then they could spend more time with their families. And like I said before, know in advance and have better confidence what tools we need to bring in order to get a machine up and running much faster.
Excellent, thank you. Okay, good. I'm gonna maybe switch directions a little bit from what we had even planned for the session, because there's a couple things that you guys mentioned that I want to focus on. One of them is, so Curtis, you talked about machine health monitoring and predictive maintenance and trying to avoid a shutdown before it happens. Is that an area that the rest of you are seeing in your relationships with customers? And is it, how much are we seeing predictive maintenance versus predictive quality? So you can put vibration sensors, temperature sensors, that type of thing on the press and make sure it's not going to give you an unplanned downtime event. But are we also, and maybe this is taken away from the conversation later, but I wanted to jump on it while Curtis brought up at least the machine health monitoring part of this. Anybody want to talk about predictive maintenance versus predictive quality and what they're seeing in the press room?
Yeah, so it seems kind of intuitive where if with predictive maintenance, why it's so important. When you see, like with our machines, when I go to the warehouses, if the oil is getting low, it kind of makes sense in order to change the oil, or so it continues to keep running. But when I go to a lot of these warehouse sites, our client sites, a lot of the machines, they're not maintained very well. Sometimes you see, even see metal and electrical control cabinets. And, to me, these very simple things like, you gotta really be on top of this and take care of your machines. What I think happens is that they're so stressed at hitting their production goals that they're always constantly on the move. But if we came up with predictive analytics or come up with simple timers like, hey, your machine's been running for 2,000 hours, it's time to change out that oil. Those little notifications will really prolong the longevity of those machine presses. But to sort of go more into the predictive analytics part, this is something that we're starting to utilize more now within our technology division. With the previous conversations, OEE was the primary standard, and now people have started to implement it, and now we're starting to get more into predictive analytics. And now we're starting to attach sensors on our devices and utilizing that data to make informed decisions. How long is a bearing going to last? So typically people will say, they'll recommend every 10 years, go ahead and replace the bearing. But, well, wait a minute, based off our sensors, and the temperature readings and the noise readings, that 10 years, this bearing is actually still really good, or this motor is still really good. You really don't have to replace it and make that huge cost investment. So that's kind of how we're starting to implement predictive analytics into our system.
Good, thanks. Anybody else want to comment on that before we move?
I will. Not necessarily predictive, but preventive maintenance. Most of those programs are based on time. There'll be a certain number of days you inspect X, certain number of months you inspect Y. With an automatic data collection system, you're tracking not only cycles in the machine, but the number of hours the machine runs. So if a machine is underutilized or not utilized a lot, there may be no need to waste time trying to do the maintenance on something like that. Whereas something that's seen heavy use, you can maintain it possibly in a shorter interval than you think you need to. And a lot of that just comes from collecting the data and knowing when the machine runs and how frequently it cycles.
Thank you. Anybody else? Okay. So, Stefan, question for you. We've just gotten started, on our webinar series this year. We've talked about it though for the last 4 years in our conferences, and the conversation always seems to focus in order to get IoT into our companies. It really needs to be part of the culture. What, from your perspective, are the steps that metal formers need to take to get started with IoT, and more importantly, really to make it part of their culture?
Well, Brad, thank you very much. It's actually a very good question. One of the first things, which is important to do, is to identify your company's challenges, or for that matter, shortcomings when it comes to various aspects of your business plan. It's important to think about everything all the way from the front office operations to what's going on the shop floor, because IoT and manufacturing is not just about production, but about the production aspect. Ideally, finding an IoT platform that can solve challenges across various sectors of your business will be the best investment and most strategic first step you can make. This will allow you to truly find what we'd say the white space, so to speak, specific to your company's and clients' needs when it comes to IoT solutions. Now, once an analysis has been completed and the challenges within your company's business practices or production issues for your clients have been properly identified, you should have an idea of what type of tool or concept, for that matter, will help your company become more effective and efficient. This is where more research comes into play. Now, capital equipment suppliers like Simpac, or for that matter, Komatsu, most likely have systems in place to help you achieve these goals. And I think that Curtis already was talking a little bit about that a couple minutes ago. Most likely, if not, they'll have likely have partnerships in place with reliable suppliers or software companies that can help. This will go a long way to maintaining a cost-effective approach while strengthening relationships with your different current and potentially new supply base. Next, make sure the IoT platform you select is versatile with the potential for not only short-term, but also a long-term impact. Find a solution that can succeed immediately upon completion as a test of sorts for both the client and your company, while also keeping a long-term ROI strategy in mind. For example, look for an IoT platform that not only offers one major benefit that you can take advantage of for the short run, such as maybe enabling virtual reality service meetings on the shop floor, but then also look at something that can expand out to something such as training and reskilling of the workforce, the entire plant's equipment inventory. This is just one example, but making sure that you can easily expand your IoT platform at later stages, you're drastically increasing your ROI potential. These platforms exist, but it's critical to do your research beforehand, obviously. Do not get sucked into selecting what appears futuristic and newsworthy, as sometimes a lot of us do, over what will achieve your 1 to 3, and in many cases, your 5 to 10-year business plan goals. Now, once you have approvals and are officially moving forward with your IoT implementations, you need to then ensure that a proper knowledge transfer takes place so that the multi-generational digital fluency is achieved. Training can vary from maintaining equipment, running and monitoring the machines, learning how to achieve optimal production outputs, and so on and so forth. Knowledge transfer is paramount to your new IoT platform to succeed. The young and eager millennials and Generation Zs will be appreciative and excited about their employers' willingness to embrace more substantial and digital environment, while the older generations, and unfortunately that's me, will not feel left behind, pending into intuitive capabilities and user friendliness for the IoT platform selected. Remember, the IoT platform is the machine, not the brain or the heart of the operations. That all lies in your team and your personnel. Next, there are also IoT platform considerations when it comes to reporting and analytics. So this is something that will greatly differ from company to company, as not all analytics and tracking is necessary. The goal here is that no matter the application selected, it's important to ensure you're not going data crazy. And I've seen this one too many times where people think that data is everything. It really isn't. Choose from the data collection options that will make your business run smarter. As that is the whole point of selecting an IoT platform. For example, metal formers can now track, measure, and report on results pertaining to employee and customer engagement, performance and retention, all in real time. While this can significantly improve upon engineering, manufacturing, and other processes, the relevance of the data captured is completely dependent on the company's internal goals and its customers' expectations. No one company is going to be the same. A lot of people are going to be different.
Yeah, good. Thanks, Stefan. Yeah, we talked this morning during one of our sessions about the role that IT now is playing on the manufacturing floor when it comes to doing these implementations and tracking data, collecting data, all the new types of equipment that we have on our plant floors now, to new sensors and Kurt, from your perspective, bringing IT onto the plant floor, I guess what do you see the role and how that role is going to be changing when it comes to implementing IoT? And Jim and James, I'd encourage you guys to.
Yeah, absolutely. I think Stefan just really hit all the big major points with this. From a software perspective, it's become a lot easier to make these IoT platforms with such a small team. You have these cloud providers such as AWS, Amazon Web Services, Azure Cloud, and Google, which gives you a lot of services needed to get the app running very fast. And to go along with Stephen as well, what's great about these cloud providers is that you really only have to focus on your application, what it's supposed to do. These cloud providers, they take care of like a lot of automatic updating in the databases, a lot of the security. So they have dedicated teams with these cloud providers that protect against the latest hacks. They have disaster recovery plans so that if something happens to your data in the cloud, how does it get transferred to a data center and continue to run your application? So really these IoT platforms could be done with 2 to 3 people on the team. You don't have to make that huge investment like we had to do in the past.
Good, thank you. So Jim and James, do you guys find yourselves working more, maybe you always worked with IT people with your product base, I'm not really sure, but do you find more and more in terms of the company culture, the IT guys have to be involved in the decisions being made on the plant floor?
Absolutely.
Yeah, absolutely. Yeah, it's.
Jim, you want to go?
Yeah, there's so much more connectivity now between all of these machines. So yeah, you end up working with the IT personnel pretty hand in glove when it comes to dealing with the company's infrastructure and all the ramifications around that.
Yeah, I find that true too. I mean, no single software product should be an island unto itself. Everything's got to communicate, talk to each other. So machine data's got to make it somehow to the ERP and the MES system. So you have application program interfaces. You have to ensure for compatibility. And we end up doing an awful lot of work ahead of time before anybody buys anything. We're working with the IT people, and they're reviewing our APIs, which are application program interfaces, to make sure that it's compatible with what they want to do. So they basically we have a prove you can do it before we buy it sort of mentality out there. And it's important. I mean, it's absolutely necessary. You don't want to end up stuck with something that's a dead end. Everything has to be able to communicate.
So along that line of thinking then, and relating it back to the culture of these of companies and how it has to evolve, any top tips or mistakes, common mistakes that you, maybe mistakes not the right word, but advice that any of you can offer based on your experiences with stampers and moving some Industry 4.0 thinking into their culture?
Well, Stefan said it. And I noticed, James, you were nodding when you said it, and I smirked inside. Too much data. You ask a customer, what data do you want to collect? And they will say, all of it. Well, it's unnecessary. You have to decide what's important to you. What are your goals? What are your goals? And then it's a matter of sitting down and deciding what information do we need to be able to achieve these goals realistically. When the customer says, I want the tonnage that it took to produce every single part, I want to put that in a spreadsheet. Well, there's no traceability to the individual part. It doesn't do you any good. But that's the sort of thing it's a battle we want to fight, because nobody wants to lose flexibility. If somebody says, I'm in charge of data collection program, I want to collect all the data just in case we need it, that's a losing battle.
Yeah, and I'd reiterate too, not only is it not necessary, it's sometimes outright counterproductive. Mm-hmm. We've seen people that want to implement 100 downtime codes for an operator to select. Let me tell you something, if you ask an operator to select from 100 downtime codes, you're going to get random downtime codes.
James, you know what I tell them? I tell them they need 101. There
you go.
The first downtime code is the operator's trying to figure out what downtime code to select.
Yep.
That's good insight. Anybody else want to comment on that before we move on to the next?
Yeah, no, topic? I think they just hit it right on the dot too. It's with data. And that's one of the problems we ran into at the beginning was, oh, we want to get tonnage and we want to get machine faults and we want to get, et cetera, et cetera, et cetera. I know we kind of reiterate this, a lot of people when they have our chats, but it's really important to start out small and then scale your projects from there.
100% agree.
Yeah. I remember when we did our first IoT experience, and I think some of you were there. One of the presentations was what did you call it? Crawl, walk, run, right? So just start slow, a simple project, and you want to start with something successful, right? You don't want to fail on your first project. So pick something and we're going to talk about low-hanging fruit later, but that's important, I think, to build the culture as well, right? To have success right off the bat, you're gonna fortify your culture that way. Good, thanks, guys. So the next topic we want to talk about is the evolution of IoT technology, whether we're talking, sensors, control, software, the whole gamut, or any part of that. But how has IoT technology evolved in recent years to make it easier to adopt and maybe less stressful on folks that are trying to get that into their stream? And Kurt, you want to maybe start off with that one?
Yeah, absolutely. So one of the most fascinating pieces of technology from a software perspective that I just find extremely fascinating is something called edge computing. What edge computing does, it just means that you're running your machine learning algorithms locally on that IoT device to do your mission critical tasks. So for example, let's just take, for example, a forklift. And if a forklift should stop if it approaches like a human object, then having the machine learning algorithm or to detect when to stop at the device, it's a lot less time, and it'll be able to say, hey, I need to stop right away. What we used to have to do before is, sends that information up to the cloud, process that data, send that information back to the IoT device in order to make a decision whether to continue operation or to stop. And that's a lot more time to make that decision. So I really think edge computing is the way moving forward with a lot of predictive analytics and machine learning algorithms in the IoT realm.
How new is edge computing and specifically to our application?
Yeah, so the concept of IoT edge computing has been around for many years, but I typically work with the Azure Cloud Platform, and I believe this has only been out for several years. I'm not sure on the exact date, but I know they have relatively new features for that.
And I'll point out too that when it comes to yeah, it has been there for quite a few years, but chip makers have made just enormous advances in these neural processing chips that can use very low power, are extremely powerful in terms of their computation capabilities, and that has really enabled a whole new generation of capabilities. We're gonna see that being incorporated more and more into robotics and things like automated fork trucks and that kind of thing as we go forward. Going to become much more common.
So how does that technology then play out on the plant floor? Is it reliability? Curtis, you said it's faster reaction time. So does that mean that the robots are moving faster without safety concerns, or how does all of this help the operations be more functional? If that makes sense.
Yeah, it definitely speeds up the reaction time. You know, what Curtis was talking about with the forklift was basically a machine vision problem. And those are very computationally intensive. And we're really in the realms of supercomputers just 10 years ago, if you were talking about doing anything in something like real time. And so as you move that computation closer and closer to the camera, in this case that's on the forklift, then yeah, you speed those reaction times up tremendously. So that makes some of those applications quite a bit more practical. And exactly what you said, that means you may be able to run the fork truck faster than you otherwise would, while still having an acceptable reaction time in the case of a hazard. It may mean that a robotic system will actually be able to better adapt its kinematics to a change in load on its effector arm. All kinds of ways that can be applied that would have been impractical not that long ago.
Yeah, and to go off of what James was saying is that if you do these algorithms locally on the IoT device, they could run offline. So with warehouse conditions, you get a lot of limited connectivity so that you could still do these mission critical algorithms offline, and you don't need to have internet in order to continue, which was the problem we used to have before this technology.
Right. Jim, you want to comment on IoT developments and technology that are making it easier to adopt?
I think standardization is making it easier. I mean, like I said earlier, we have to communicate with everything now. And it's a lot easier to do now than it was 10 years ago. James can probably attest to this too. You have a software system that needs to get information to other places, and it's much easier now, and it's going to get easier in the future.
Yeah,
by the way, don't underestimate the impact of the smartphone of all of this too. I mean, now somebody has a Star Trek communicator in their pocket, and just everybody's connected. Everybody has the ability to do it now. I mean, I was involved years ago with people who were forced to wear pagers, and they hated it, they resisted it. They used to put the pagers on a table, set them to vibrate, and they would bet on a pager race to see which one made it to the edge and fell out first. Now everybody has their own smartphone, so if you need to text a fork truck operator or a mechanic or an electrician, they can get an instant notification from the machine with no human operator involvement that something needs their attention. And it can be escalated too. So if they don't get over there and take a look at it, their boss gets a similar text 15 minutes later saying, hey, we sent a text to Finity, he was supposed to go over and fix this thing, and he's out, you know, messing around with something else. So communication and connectivity is huge.
Yeah, good comment. Tablet computers as well, right? We're starting to see more and more tablets show up on the plant floor. Stefan, any additional comment?
I think that's pretty much the, you know, both Jim and James have nailed it right on the head. I mean, you know, that's one of the things that, you know, Jamie found for us here at SIMPAC when we were talking about our XR technology, is trying to make something as simple and as user-friendly as possible. And one of the things that Jim said, yeah, your cell phones. I mean, you know, I'm old enough to remember when they first came out with bag phones, okay? And now everybody has, you can't pry a cell phone from somebody's dead cold fingers anymore, right? I mean, so the whole thing is if you can do something that's user-friendly and easy that everybody works with on a daily basis, it's going to make the not only the younger generation, but also the older generation more you know, acceptable to the idea of IoT and to the new technologies.
Yeah, since you brought it up, Jim and James, the screen that folks see on a press control, what can they see on their phones, if anything, as the press is running? Is that a thing? Can people? Go ahead, Jim. You're nodding your head.
It's very much a thing. With remote access, somebody can actually view the screen that's on their press on their phone, and with the right permissions, they can help with application issues or programming or anything else. What we've found, and James, I'm sure you find the same thing, our companies, for those of you that don't know, we're competition. We make control systems for metal stamping presses, and I'd like to say we make the most comprehensive controls there are. And the high-end controls, they can go on any machine. We can put them on a small high-speed press, a gigantic transfer press. There's hundreds of different functions. And the operators understand what they need to understand to be able to run the press on a day-to-day basis. However, there are a few subject matter experts in every facility that have a greater understanding of the control. And when an operator has a question that they don't understand, they have to track down the subject matter expert. Well, now they can notify the subject matter expert, I need help, right from the machine. The subject matter expert can pick up his phone, log into the machine, see what's going on, and either fix it or explain to the operator what needs to be done. And the remote access, especially during the whole COVID-19 thing where so many people were remote, was huge, absolutely huge. And that became pretty much a necessity at that point.
Yeah, and I'll expound on that too from the side that while, you know, extended reality is very non-trivial to implement right now, one of the parts of it that is being used, I think, very successfully is where a remote technician can be looking at what the operator is looking at. So not necessarily even on a screen. It could be on the mechanical aspects of the machine or an electrical panel. And so they've got some pretty nice situations now where that remote technician can even kind of circle something in the view of the operator and say, hey, you need to take a voltage measurement here. When you think about the time and effort that saves versus having to have a factory tech travel someplace and come in, it's incredible.
Or the half-dozen phone calls.
Well, don't forget also, it wasn't just the time and everything like that, it was the cost too. Because I mean, you know, that customer, if, you know, if I or Curtis as a press manufacturer have to send somebody out, we're not doing that on goodwill. You know, that's costing, you know, X amount of hours of travel time, X amount of hours for somebody to be there. Now with the fact that either you or Jim can quite literally look on your cell phones or tablets for that matter and, you know, tell somebody, hey, listen, you know, take a look at this, you know, press that, look at this right here, and you can do something in maybe 30 seconds up to, or maybe as much as 30 minutes, but from the remoteness of your own home, it makes things a lot more effective and efficient.
All right, good. Any other comments on that one? Talk about that for a while, probably. Yeah, I mean, we starting to see, I mean, I remember seeing it at shows years ago, the glasses, the XR glasses. And they kind of disappeared for a while. Now we saw them again at FabTech this year in a few of the booths, and so maybe that technology is finally, I think to your point, Stefan, it's more affordable, maybe more reliable now, and maybe not so space age for more of the people that are now working in our facilities. Yeah, obviously from a remote maintenance perspective, it has a lot of potential.
Well, if you're looking at, just to hit on that real quick, Brad, because I know we're time limited and everything, but when you're looking at COVID and you're looking at whatever kind of sicknesses or craziness is going on out in the world, it's sometimes a little bit irresponsible to have a headset device that you're passing from one person to another with, but since everybody has, like both Jim and James were saying, has a cell phone or a tablet, it makes it a lot more user friendly and easy. And of course, the whole thing you also have to take a look at is the cost ramifications of the technology that you're trying to implement. We as either salesmen, marketing people, or engineers for that matter, sometimes don't look at the dollars and cents. We just look at the really cool gadgets and gizmos. But then you always have those ugly finance people in the background and everything like that bring us back to reality. Companies got to make profits, and it's got to be robust. And I'm not saying that the ocular devices are not going to become something mainstream in the future. I honestly do believe they will. But over the next 1 to 3 or maybe even 3 to 5 years, I believe, just like what Jim was saying and showing with his cell phone, and James was talking about as well, your tablets and your iPhones, that's going to be where it's going to be at least for the next short to midterm future.
Gotcha. Okay. All right, good. Let's move on to our next topic, which we touched on a little bit earlier. And Jim, you talked about low-hanging fruit. I think you used that term, and I think OEE falls into that realm. But from your perspective, Jim, and the rest of you, after Jim talks about it a little bit, what do you see as low-hanging fruit that metal formers are already using for IoT, or if they're not, then they're probably already behind the 8 ball a little bit?
Well, Brad, there's plenty of it, believe it or not. Actually, you probably know. One of the things I've found with a lot of users is until they start doing real-time data collection from their machines, they have an inflated idea of how efficient their machines are. Mm-hmm. This may be shocking to all of you, but I have pretty good sample size that tells me that the average metal stamping press in North America has an overall equipment effectiveness of 38%. So the OEE is about 38%, which means they're only 1/3 as effective as they could be. Now, really brief, let me explain what OEE is, because I hate undefined acronyms and I'm not sure everybody knows what it is. Overall equipment effectiveness takes into account 3 factors: the percentage of the machine is available, the performance percentage, in other words, how many parts did it produce over a period of time versus how many could it have produced had it run at the maximum speed, and how many good parts did it produce versus total parts. So you multiply availability times performance times quality, and that gives you overall equipment effectiveness. Now, the OEE is most affected by availability. And when I say, let me qualify that 38%, that's all the stamping presses in North America, even the secondary operations that may not run as frequently, but even among what most stampers consider their heavy runners that they assume are running all the time, you're looking at an overall equipment effectiveness of about 60%. And there's a lot of factors that enter into it, and it's different from plant to plant. But the first thing you have to do is you have to start collecting data from the machines, just to know how efficient they are, when they're running, when they're not. And when they're not running, you need to get an idea of why they're not running. You need a reason for downtime. So once you have the number of parts they make, the reasons for downtime, and you're accurately getting OEE measurements, only then can you begin to improve. And the low-hanging fruit becomes pretty obvious. If you install a real-time data collection system, there's an automatic increase right off the bat. It's a temporary bump. It's called the Hawthorne effect. I'm not going to explain what that is because the story behind it is probably apocryphal, but really just by being watched and people know that you're concerned about the machine's uptime and downtime, you see an increase of efficiency of anywhere from 5 to 10%. And as I said, it's probably temporary as people get used to it, but if that data collection starts to initiate a culture change, then not only does that 5 or 10% become permanent, you start to make improvements all over the place. And some of them may not be as obvious as others. You can compare downtime from one machine to the next. We recently had a user that had almost identical machines, ran the same jobs. And it was a low volume, high product mix manufacturer. So there were a lot of job changes and a lot of coil changes that went on. One press had a double-ended reel, one press had a single-ended reel. and they compared changeover time, again, coil change time for both of those machines, and they were able to justify the purchase of a new double-ended reel for the machine that didn't have it. Now, this is something that they had requested for years because it made sense. They knew they needed it. But once they were able to put numbers to it, as Stefan said, that the bean counters or the accounting people, it was undeniable. Something they resisted, and they said, here you go, here are the numbers. And they said, we have to get this. Well, sometimes it becomes obvious. So the return on investment can come through investment in equipment. It can come with reallocating resources. I mean, very few places now run one machine with one operator. You have several operators running several machines each. Some machines may require more attention than others. One of our customers had a machine that had a chute at the end, a movable chute at the end, and they were running parts right into a box. And when one box filled up, the chute would move over to a second box, and the operator was expected to come over, close up the first one, and put in an empty. Well, the operator complained for years that we need an index table, so I don't have to go running over there, when these boxes fill up quickly. So they found that when that operator had to run an equal amount of machines to the other operators, all those machines' efficiency suffered. Whoever was burdened with the machine with the box, all the efficiency of all their other operations went down. So that became a simple matter of, until they were able to justify the indexing table, they moved that operator on a fewer machines and spread the burden around the others, and efficiency went up. Little things like tracking setup time. Track setup time by operator. You'll find out who your best setup operator is. You have that operator train the others. So some of the low-hanging fruit is obvious, some of it isn't. But what I said earlier before, this is something I found to be true. If you ask somebody what's your major cause of downtime, they tend to bring up catastrophic events. We busted a tie rod in this machine, or we keep having to replace the bearings, or we're running too much reverse load on this machine, or this drive burned out. Everybody remembers the catastrophes, but the catastrophes aren't the problem. It's the little things that you're used to, that you're taking extra time for, that are killing you. One user I know of has a very, very high product mix, low volume with about 20 machines and about 8 job changes per day per machine. So the way they do it is the operator would set up the next job to run, and then the QC person would come over, verify the setup, and then allow the operator to run it. Well, each operator and each QC person was responsible for multiple machines. So they had an amazing amount of time. It was about 20 minutes of either waiting for the QC person to come over or waiting for the operator to come back. So what they did is they created a couple of new downtime reasons. When the operator was done setting up, he'd hit wait for QC, and that was the downtime reason. When that happened, the QC person would automatically get a text on his phone saying, press number 5 is waiting for QC. When the QC person was done, they would select the downtime reason, waiting for operator, and then the operator would be notified. Well, the average transition for a setup waiting for QC and operator was 20 minutes, and they were able to cut it in half. Now, that may not sound like a big deal, but at 160 job changes per day, 24-hour shift throughout the plant, they save 1,600 minutes a day in downtime. So it's not the big things that are killing you, it's the little things. And once you change the culture and improve it, that payback keeps coming in. It's not a one-shot deal. It's day after day, month after month, year after year.
Yeah, good stuff. So what do you see then as, if 38% is the average OEE, what's kind of best practices out there?
In the 70s.
Yeah?
Yep. You can almost double it.
Wow. Okay.
But there comes a time,
James? Oh, go ahead. I'm sorry. Go ahead. I'm sorry.
There comes a time when most people, when they install this sort of system, they get almost all of the benefit in the first couple of years, provided they're active and they do something about it. You start a downtime reduction program, and you pick the really low-hanging fruit. Then you pick the medium-hanging fruit, and then you get up your tiptoes on the ladder and pick everything you can. And there comes a point in time where it doesn't make financial or business sense to try to improve upon that. Well, what makes the data collection system worth keeping around is the improved communication, because then your efficiency is largely going to depend on how quickly people can respond to exceptions, to problems, to needing things. And these data collection systems, provided they're in real time and they're automatic, they can get people to respond quicker. And with that escalation feature, you have the further pressure management, making sure that people do respond in a timely manner, and it makes the system worth keeping around.
Excellent. Kurt, you want any comment on all of that Jim just went through?
Yeah, kind of to piggyback off what Jim was saying, how the OEE is very important, and I feel like that's a great metric to start monitoring how well your machines are producing parts. For me, and other people might have a different opinion, I don't like to think of OEE as like a grade where like 90% and higher is an A, 80% to 90 is a B. I like to think of it in terms of, okay, so our OEE for the day that we calculated was 30% today. What can we do the next day to just increase that number a little bit so that we're able to get better production results? And kind of like what Jim was saying, that if you could see these little things that are causing the machine to temporarily stop, what's great with recording that is that you could see patterns. And with these patterns, we can go ahead to our engineering team and say, we just lost an hour because of this given machine fault. What are some solutions we could come up with in order to minimize this time and increase production?
Good, thanks. Anybody else, James, Stefan?
Yeah, I'll throw a little bit more on the fire there. I absolutely agree with Jim on one critical point here, is that in our experience, nearly nobody actually knows what's going on with their machines. And one of the biggest deals to this, I mentioned this veil that has been over our process data. When we actually get process visibility, real process visibility, things stand out really, really fast. And just as another example of what Jim was talking about, where people tend to overemphasize those really big catastrophic events. We put in a system and we had an automatic running press that theoretically was running at 60 strokes a minute coil fed. And I look and it's making 5 strokes a minute. And I go down to this thing, and this is no joke. This has actually happened. There's a vibratory scrap feeder that's feeding scrap out of the bottom of this die. And literally what's happening is the thing is getting hung up about every 10 or 15 seconds. And the operator would stop the press, claw the scrap out of the chute, restart it, rinse and repeat for the whole shift. Mm-hmm. Nobody but that operator knew what was going on there. And so that's a huge, huge big deal. When it comes to low-hanging fruit or just the effectiveness of this stuff, just the visibility into what's actually going on with the press is huge.
It's the simple things.
It's the simple things.
Right. Okay. I want to be respectful of everybody's schedules, and we're kind of at the bottom of the hour. Anybody in the audience have any questions, please fire away using that question panel. I want to bring up one last topic while we're going to wait and see if we get any questions. And we talked, a lot of data. There's a lot of data you can't capture. What's the right data? What's nice to have versus, what's must have. From a managing the costs, then, Kurt, maybe you can talk a little bit about what you're seeing in terms of what's the right data, what's nice to have versus must have, so that stampers aren't spending an inordinate amount of money collecting data that maybe they don't necessarily need.
Yeah, absolutely. So I kind of briefly talked about, cloud resources you could do. And like with saving costs, I highly recommend, if you're going to build an IoT application, to use a cloud provider instead of building on premise. You don't have to hire as many people, and you're going to save a lot of money. But from a data perspective, though, I highly encourage you to ask this question when you're trying to create a new application. Does the information have to be in real time? Or do we have to just retrieve that information maybe once an hour or at the end of the day? Because with most cloud providers that we typically work with, you have to pay per message you sent up to the cloud. So for example, we were talking about the OEE, so I'm going to use that as an example. With the majority of our clients, they want to see this, but they generally don't want to see it every second. So, you know, from a cost perspective, if you constantly send OEE calculations to the cloud every second, you're going to blow through a lot of your resources pretty fast. But typically with our clients, if they you know, they just want to monitor what's going on in their machine at the end of the day, or by the week or the month, or in their meetings that they have. So we typically don't calculate the OEE every second. You know, we typically do it maybe every hour, and that's sufficient for our clients. So always thinking about what the client wants too. And yeah, kind of like what we were talking about before with data. Everybody wants everything, you know, they have big ideas right off the bat where I want to monitor everything. And then where we were kind of talking about before, people run into these problems with, well, I don't know what to do with this data. So really think about the infrastructure first. What's going to be useful parameters that's going to help us in the long run, and what parameters are going to help us with good return investment, such as measuring how many units you made for the day would be a really good parameter that could help you down the road. So my goal for today was to make 20,000 units, but I only made 10,000 units. And then you could sort of come up with ideas. Well, gosh, you know, I was nowhere close near my goal. What are some ways in order to increase the efficiency?
Sure. Okay. Anybody else want to comment on that? What's the rate data? When's the right time to get it? Must have versus, you know, versus nice to have.
I think
one of the important things about data is you don't want to have the same data in two places. So if you have a whole library of part numbers with expected production rates or ideal rates or anything like that associated with them in your ERP system for quoting purposes, you don't want your data collection system to have to judge OEE based on its own rates. So communications between systems is really, really important when multiple systems need the data. You should only be keeping it in one place.
Sure.
So that's a really important thing to keep in mind.
Makes sense. Okay. James or Stefan, any last comments on that?
No, I mean, I think it's pretty much it. It really comes down to what the customer needs versus what they think they want, and that is it's an important discussion to have on the front end of implementing one of these systems. Is, you know, what are you looking to get out of it, and how are you going to use this data, and then that really determines, you know, what those rates are and what you're collecting. It's an important conversation.
All right, excellent.
Make sure you dot the I's and cross the T's before you start spending money.
Right. Good advice for everybody. Hey, excellent. All right, so we've gone over a few minutes, so we're gonna go ahead and wrap this up. So I really want to thank our panelists for joining us today and giving us your valuable time, and of course want to thank our attendees as well for logging in today. We hope everyone found it to be valuable, and again, the program is recorded and will be archived on our website, so everybody will get a link towards the end of the week. You'll be able to check it out online, share it with others, that kind of thing. So yeah, please join us then tomorrow morning, 10 a.m. Eastern time, for part 3 of the webinar series on IoT. We've got presentations tomorrow. We talked a little bit about it today. I think we're going to focus more tomorrow on not only how to build Industry 4.0 and IoT projects, but how to build the right team to get you where you need to go. So join us tomorrow at 10 a.m. Eastern for part 3. We wish everybody a great afternoon, great evening, and we'll see you tomorrow morning. Close your browsers now. Thanks, everybody.
Hey,
Thank you.
see you, everybody.
Thank you.
Thanks a lot, Brad.
Thank you.